Alafu kukula mnani.
Play that one with me when they say yeah, because this one I don't miss it.
I thought no, I don't say it, but wait.
You see what connects there? You see what connects? No, I need to listen to.
I don't connect.
Okay, now you the player. Ask me the player. I did do. Yeah, take it is that's a good thing. And it's right from them and pass on other food because it was a lady for long. This thing I was there.
You know, we are opposed to assembly platform. If you know this thing, I keep on against it. What I am. I trust site today. They say there's tickets. Track one never finish. You know. That's one. Track one never finish. Track one never finish, but won't be. You be no day. Why? Check it now. There's one will be. Track one will be for today. There's no to be will be for today. I got it now. Schedule. I'm telling you. You will be no day. And you need to do that. If those are not presented, they should come to the hall for their presentation. Let's do it that way. There have been any challenges, maybe in the other, let them move to the hall. All the technical IT guys, they haven't. No, we just need them in two venues. So I cannot go to VC former conference and then Phantom Lab. We are still today. That's great. Steven, wait, you know what you have? Steven, I still just say, if person don't accept everybody, so share a link so those people when they online, see. So it's also person where also Sabian will understand well. So now I was telling them that because I don't know you said when I don't it was when I bought my system. I see that it's something on my system. Say something is wrong. I now said, oh yeah, no,
Fine. Good morning.
I think I'll say because I want my DJ going so I my
No, good morning. Hello. Hello.
Good morning. Good morning, ma'am.
Good morning. Please, I wish you can do that while you engage in that your discussion.
Hello, everyone. Good morning. We'll be starting very soon. Please, let's settle down. Good morning to those online. Can they hear me? Those online.
Very
We can
well.
hear
Good
you.
morning.
Good morning, our online participants. Can you spotlight them? Spotlight them. Let's say good morning to them. Our online
Yeah,
participants, can you
we
hear
can hear
us?
you actually. We can hear you.
Oh, great, great. Good morning, everyone.
Yeah, good morning, Dr. Adora. We can hear you.
I welcome you all. Our online participants, can you hear us?
We can hear you.
Oh, great, great. I welcome you all to the second day of our second international conference.
That is for Dr.
And thank God for yesterday's events.
Section kìíní má ti ṣe.
Thank God it was a huge success. And we pray that today will even be a better day. So we're starting shortly. You're all welcome.
Breaking section má ti ní. Ìwọ tó bá flash balẹ̀ sí ní ilé fáìlì náà. Síbọ̀ bí ti lọ sí olóṣèlú yìí dé ìṣùgbọ́n system tó yẹ kí n take kìíní ìlú ní ìfìlú. Kìíní send it to WhatsApp. Wọ́n send exactly that. Wọ́n send it sí WhatsApp. Yes, sir. That would have been the best option for me. Entertainment. First of all, one. Only that one. Two. One the lower one. Two. Then you send you this soft copy and moving become. I get in there. Yes. Okay.
To make his presentation, I'll leave his small bio, a brief profile before I call him up the stage. Dr. Kelvin is a senior lecturer in electrical and electronics engineering and director of the Center for Future Technologies at the University of Chichester, United Kingdom. Specializing in smart digital infrastructure, telecommunications, and next-generation energy systems, he has built a robust career as an academic researcher and professional engineering leader. He earned his PhD in communication engineering from the University of Bradford, an MSc in data communication and networks from the University of Salford, and a BSc in industrial physics from Ebonyi State University, Nigeria, where he graduated as a top student in his class. Prior to his current tenure at the University of Chichester, he gained extensive academic and research experience in the UK higher education sector, serving as a lecturer at the University of Bolton and working as a postdoctoral research associate at Manchester Metropolitan University. As a highly active researcher with over 80 peer-reviewed scientific articles, Dr. Arnold focuses on the intersection of communication engineering, smart infrastructure, and artificial intelligence. His specific research interests include smart grids, smart cities, signal processing, IoT-enabled cyber physical systems, embedded machine learning, and cybersecurity. He has contributed significantly to major high-impact initiatives, including the EPSRC-funded Smart and Building Microgrid for Energy Management projects, and the 30 million euro Commission-funded Triangulum project on smart cities. He also extends his expertise internationally, serving as a visiting associate professor at Novena University in Nigeria, and as a member of the Early Career Researchers Committee for the Supergen Energy Network Hub. In addition to his academic and research contributions, Dr. Annan holds vital positions within international and regional professional bodies. He is a fellow of the UK Higher Education Academy, director of the IEEE Club Region 8 UK, and serves as the technical secretary of the Nigerian Society of Engineers, Manchester branch. Within the University of Chichester, he coordinates external student engagements with key organizations like the IET and IEEE, and serves on the university's Research Ethics Committee. A frequent international speaker, he regularly delivers expert talks on enabling technologies of smart energy cities and edge computing on optimization at global conferences. Please may we welcome Dr. Annan with a round of applause. He comes to the stage.
Amen.
Sure, well, actually.
Well, second, you should copy. You see this.
Hold on, this topic.
All right, so thank you very much, everybody. And I'm glad to thank Dr. Adora for that introduction. And for our colleagues who are online, I hope you can hear me. Our friends online. Can you hear me?
Yes, Doc, we can hear you.
Excellent. So I will be talking about the infrastructure, smart energy infrastructure that we can use for a growing economy. And I believe Nigeria is a growing economy. Yes? So if you take me to the next slide, please. Just before I talk about those technologies, let me talk briefly about CFT. You must have heard of CFT. CFT is the Center for Future Technology that is within the University of Chichester. Do you want to go to the next slide? Is this guy paying attention? Excellent. So we are within the University of Chichester, and the Center for Future Technologies is one of the research centers there. So I lead one of them. So on the left-hand side, you see the university logo with our VC on top, Professor Simeon Dax. And the recent, what you see next is the recent university rankings. There are 123 universities ranked in the UK. Ours came top within the first third as the number 28. So that's an indication of the type of things that we do within the University of Chichester. So if you are looking for opportunities to collaborate, we are very much open to welcome you to join us. Let's go to the next slide. So we've had a very good relationship with the Federal University of Allied Health. And that relationship has lasted over some time, producing some of these research outcomes. And it's childhood that we see just examples that are more than this. So we are very much committed to supporting the university, the Federal University of Allied Health.
Sorry, Prof, please, I'm trying to.
Okay.
So,
the next slide, please. So within the CF, I'm talking about CFT, I'm not longer talking about the entire place. Within the CFT, we have some programs. Difference between what we do there and what we do here is that engineering is 3 years. Here is 5 years. So, except that the difference is the entry requirement is scalable. Okay, you can go in, you can be admitted in another way. Okay. So we offer mechanical engineering, but if you look at, apart from those degrees that we receive at the end of studying with us, there are different routes to studying with us. First one is the DA, which is the people that work inside companies, but take 1 day or 1.5 days to come to the university and study with us. So by the end of 4.5 years, you get it. So that's one aspect. The other one is, yes, next slide. So we offer as well manufacturing. And next, and we do computer science, MSc in artificial intelligence, and we do math. So all of these are my sector. Next. And there is also the biological spaces that is attached to us. And the interesting thing about the biomedical sciences that we offer is the CDC, which is those facilities that you are seeing there, the Mobile facility. The UK government wants to be into 202 community diagnostic centers. So out of which 170 has been built. And we are lucky to attract one of them. Part of the things it's supposed to do for us is to help us discern, understand why the life expectancy of people who live in Bognorages, which is just 15 minutes away from Chestnut, to die 14 years earlier than others. So, yes. So if you launch that, so what we do here is basically CT scan. So they scan patients and then the results go to the database for research and also the patients who are down. Okay. So robots. We build robots. The popular examples are the fighting robots, which has won several. Go to see where they are competing within the arena, where we call the arena, the fighting range. And this is not the only one. There are many other examples of what we do. So this one is really happening inside CFT in what we call arena within this CIA. Okay, if you move to the next one, please. So we have several technologies that we've been, trying to deliver to solve energy problems, environmental problems, and then to contribute to the both national, the first one that we see CP 2030, the UK government wants to generate all their electricity, not energy, all their electricity from local resources. At the moment, they import electricity from neighboring countries. So since the war between Ukraine and Russia, so there is some problem in terms of the energy bills. So they are looking to protect the citizens from what they make off of the petrol states. Petrol states are those countries that depend on petrol for their economy. So what they are is trying to, how can we use all the resources, natural resources that we have to generate electricity that we can use or that we need. So that's the CP target. So our solution, what we've been trying to do, number one, is we took plastic bottles, these ones we produced yesterday, for example, and then we created some very interesting 3D prints with solar panels on top of that, and then with some interesting LEDs. And what that will do is that we can easily give you this knowledge, and you go back to your house, reproduce this, more especially for people who live within the area where there is no constant electricity. So you can actually take this, go to your house, and then charge that for yourself. And that power gets you some reasonable amount of electricity. So we've been into different forms, and it's getting renewed. We build both artificial intelligence into the new model, and so on. You want to go to this slide? So the other thing that we built is this. In terms of data communication or data transfer, if you work in defense, you will understand the difficulty of trying to pass on several secret files so that it cannot be picked up by the next person. And one of the things to do is to use this human body communication. So, like the young man that you see there is some data from point A. That data can pass through him, through his hand, to the young lady, and down to the point B, which is the receiver. All those things will be. So the device, the second device, will run exactly on the body of the lady, and the third device will be another device and the guard. So with the guard, what's the next time? So we actually deliver this. James worked on this, and fully worked on that. So we can actually transfer files through human beings. And what you see on top there is the pig tissue. Just use pig. We went to the market and then one of the shops. Then we bought some pig during the experiment. But now the experiment is complete. In the lab, we tested during the presentation. We actually transfer files. Just where there is a wearable device, that part where it can be, and then the receiver going to wear on the other hand. Just let me, the file get transferred to you. Okay, thank you. So the next one is the one that I haven't worked on. Is these days we have growing populations that are becoming older. And in the UK, unlike here, they live a kind of independent life. So their aged ones, and of course some disabled people, do not have people to support them. So what we did in this case was traditional old microwave oven. We took that. Everybody knows what that is for. You use that to cook food. Yes? So what we did was we took that microwave anytime we want. Then that part that I circled like that, we worked on it. On top of that microwave, we implanted camera. That camera will take the picture of that food, send it to LLM. Then it will determine the number of minutes that it will take to cook that food. It will send it back to the microwave. Microwave cooks the food. So this has been delivered, it's working. So the version, the version that has been delivered in the lab and has been demonstrated that works is what you see. So that's the panel that we 3D printed within the lab that we used to replace that came from the manufacturer. So with the AI, there are a lot of good things. I saw the young man that was arguing about AI yesterday. With AI. Okay. Now, can you take me to the next slide? Let me talk about smart energy infrastructure for a growing economy. Nigeria is a growing economy. Go to the next slide. So what I have proposed is, or what I've been working on for the past 10 years, since 2016, I've been talking about smart infrastructure, smart energy infrastructure, and so on. I've talked about this in several countries. First time I spoke about this in Mexico, and then I've gone to several countries to talk about this. Now, the idea is this. The whole picture will be the primary source will be renewable. Yes? Why? Because it has to conform with international standards. Now, I'm not saying that we should get rid of all the electricity infrastructure that we have at the moment. It is something that is going to grow gradually. At the moment, Nigeria generates about 4,000 megawatts. 30% of that comes from hydro. 70% comes from thermal. Now, when I listened to one of them, they told us that the hydro, the capacity of hydro is up to 7,000, but the maximum that they're generating now is 400. And even on top of that, that they do not have infrastructure to deliver the capacity of that system. So what we are proposing is the system can be entirely renewable, and then we will feed it into a smart electricity grid. What is smart electricity grid? In a very layman language, think about it as power cables, electric wires, all those systems, generation and whatever, down to distribution, down to consumption. Then on top of it, you put a layer called ICs. So if you write that in a simple math, it will be that a smart electricity grid equals the grid, which is the electricity grid, plus ICT. So on top of that, you will have some storage systems. And in this case, I've said batteries. But I will tell you about other types of batteries. Now, those energy that, or the electricity that you generate in that case will go through some process depending on what you want to use it for. If it is in terms of transport and so on, then it will pass through that, the first segment, and you use that for electricity, for fuel and so forth. But for homes, for domestic use, what you can do is not usually emphasized here, but what you can do is to take that part of that electricity to drive your heat pump through some thermal storage down to your home to generate hot water cooking and so on. Yes? Now, if we move to the other slide, one of the examples that we have done, this one is what we demonstrated this in SHIP, is, think about it, if you have some homes, one on the right-hand side are homes where people live. These guys have some central storage system, which we label there as ESS. That storage system will traditionally pass through what we call the EMS, the Energy Management System. So the electricity from the grid can actually pass the EMS down to the battery. The electricity that is generated from renewable, and the example we used here was the PV. It will pass again through the energy management system and so on. Now, but if you look at this, there is a part of it which will determine the parameters in terms of what is the weather forecast, what is the temperature, what is the price. Because if you connect it to the grid, you will check when is it best to buy. In the UK, it is usually cheaper to buy at night than during the day. So, and also look at the load. This would determine whether these guys will sell or whether they will not, or whether they will buy or not. Okay, if you move to the next slide. Now, this is a storage system that we can use. I know Nigeria generates a lot of oil. And then, but after the oil, when it dries up, what happens? What happens to that? Well, so they feed it up, or what? I have an idea. Look at this. You can compress air into that hole. Then that air, you can take it back when you need the electricity. And then pass it through from heat exchange and mix it with natural gas. And then that high pressure air will now turn the turbine. The turbine will now generate electricity. Simple principle of electricity generation that found about. So, if we have oil wells that are private, what we can do is tell them to feed it with sun. Let's use for energy generation. Yes? Okay. So this is another project that we worked on, which Dr. Adora talked about. So on smart cities, the European Union gave us 30 million to work on this project. And the three cities that participated were Manchester, Stavanger in Norway, and Mediho in Netherlands. Next slide, please. So Siemens gave us this battery. And what happens is, on top of that building, because this battery is next to that building, the energy that they generate from the solar panels on top of that building will be stored inside this battery. And when it is needed, the house will use it. So that house, there is also some CHP that is attached to that building that supports the electricity supply. And the next slide, please. So we talked about notions that we made to this in terms of smart energy, smart mobility, and then collecting data about all of this. Then those guys that like machine learning, artificial intelligence can use that to do their learning. Next slide, please. So when we did this project, it was on Oxford Road, which is in Manchester. So then I was affected. So then the problem we had was this road was one of the busiest. In fact, this university is the Manchester Metropolitan. The other side is the University of Manchester. So two of them are just on the same road. And the traffic here is usually very bad. So, and all of these problems are available. Now, what we did, when we went on it, to the other slide, next slide, you see that the problem has been solved. Number one, there is a place where people cycle. And the UK government really encourages this because every 4 persons you see in the UK, one of them is diabetic. So they are looking for ways to make people exercise instead of driving or using their personal cars or buses. So you see where people can walk and where the car can, buses can move, and where the pedestrian can also wait. There are many other examples that I can give, but I think I would give you 5 minutes. Please ask me questions. So this one is the one we want on hydrogen. So this is the one we did on hydrogen. And then next one is around Portsmouth. So there, you see that down that part, you have ships there, and there are heavy good vehicles that go there to get the freights. And when they pass through this road, they generate high amount of emission. So what we were asking, can we replace the fuel that these heavy vehicles are by hydrogen? So we did a scan using some GIS and then mapped and determined a location just after that Portsmouth area where we can generate hydrogen. So there are quite a number of them, and we got that results. And this one is the one peer-to-peer energy trading. We worked with Oxford Imperial College and some very good friends from South Korea. And all of this, we developed all of this solution. And now I added agentic AI on top of this. Now, where this comes in is not at this stage because of the age where our electricity or energy network is. Yes? And you saw very nice mathematics, and I will ask this man to help. Thank you very much.
Thank you very much, Dr. Anon. Please, can we appreciate him? That's honestly, he really deserves it. Things that we really never thought were in existence. They have proved to us today that they are really in existence and they're really working to do better things. Please, let's appreciate him one more time, please. Now it's the question and answer session. So I want to invite Profina to coordinate this session. let's continue on the existing protocol. Those of us online, I hope you can hear me. And you've also heard everything that our guest speaker has for us this morning. Please, what we want now is questions. If you have questions, please indicate so that you ask him. You know, he has talked so much about the future technology and even the world we have here. Now, these days, you don't need computer again. Your own body is not computer. Just carry that paste and start transferring your files. It's wonderful. So, yes, please come forward. Yeah, please come forward. Come on. Thank God he's around. So, Dr. Anna, at least you can come close to the stage so that the people online will also see you.
Thank you, Dr. Anna, and for your presentation. Please, as a way of technology transfer, because I believe that's part of the outcome or the result of this presentation. Is there any program or plan, and being the head of the Center for Future Technologies, is there any plan for younger people from this part of the world to, acquire learning and skills that will enable Nigeria maybe to be part of what is going on the global stage, maybe in form of training and scholarship for younger people that are interested in artificial intelligence? Is there any such plan or program in place? Thank you.
Thank you. I think since Dr. Anna is here, he will be answering the questions.
Thank you very much. You didn't tell me your name. Oh, I forgot. The answer is we have several programs. We are partnering with Ahiaise local domains and to provide several skills-based training. And this is highly supported by our center. So if anybody doesn't know about it, I'm introducing to you the Ahiaise local, something people have benefited from and are still benefiting from. In fact, Skill Up Hub was the major sponsor of this conference. So, and also I personally offer personal mentorship. So get in touch, I'm available online, and then we can talk, anything. Just drop me an email, we can always work around that. And I work with Novena University, and I'm very open to work with other universities as well. So,
yes, it's on screen.
On the screen.
Thank you very much. We'll get another question, please, this time.
Thank you very much for the wonderful presentation. I was imagining whether we're still on the same planets when the lecture was going on. But I heard my breath. Let me ask you whether some of these things, I know that the problem we have here is funding. But can this thing be replicated here? I know that some of them are not too high-tech experiments, but can it be replicated here? And if yes, how can we get involved and see how for instance, the hydro electricity, you said about 30%, and then the turbine and all that. We should be growing beyond that now. And someone was asking me, is Nigerian government aware that this kind of technology is available? And I said, I must confess, yes, that Nigeria will know, but the political will may be the problem. So, but at the academia level where we do these things and then transform into industry. Is this thing doable in this part of the world? Thank you very much.
Right. If you go to, can you move slide where we have the smart plastic light? Here. When we deliver this project, a charity organization approached us. They support Uganda, they support a school in Uganda. So they approached us that they want us to help them, deliver this technology to the people of Uganda. So because we want to reach out, we want to help. So we said yes. So if this type of thing is common, yes, we can usually, if there is anything that are presented on the likes of thing you want us to replicate it here, then let me know. And then when I go back, we can make arrangements for that.
Online, we have somebody is raising hand online, and this is Okoro Osaho. Please, can you bring your question up? We want to hear your question. Unmute yourself.
Okay. Thank you very much for the opportunity. Prof, I really enjoyed your lecture, and I'm actually doing my research in this area. But I listened to the compressed. The oil is empty, and turning the turbine to generate electricity. In the absence of that, if we have maybe some water tanks in an overhead at a particular height, and then we now have magnets installed to the flywheel to kind of hello, can you hear me? Hello. Okay. So okay, no problem. Let me continue. So what I'm actually asking is this: I know that we will to send water down like the form of hydro where the turbine will be turned. We will need a massive water bed. But I'm thinking of a solution whereby we include magnets to the shaft of the turbine that will create an initial movement already that will be summed together to the force or the torque that will turn the turbine. Is there any possibility like that? I don't know if there's any research already on that angle whereby magnets can be used to excite or start turning the shaft already, so that we can merge two renewable sources together to turn a turbine to create energy or to create an energy source. That's my question.
Osan, what you're talking about is a fundamental engineering problem. Do you want to move? So, when you have magnets, or if you return back to the fundamental physics, when you have magnets, or do you know about motors, different types of motors?
Yes.
Yeah. So if you look at that basic engineering, so what you expect to have, so this man is asking us, although it's not this one, you are asking about not this one, but yes, this one. Is that correct? Are we together here? So if this is what you were talking about, so you want to create a motive kind of motion that is going to rotate a shaft.
Okay.
That is going to rotate a shaft. And that shaft will be the one that is going to generate electricity. Yes?
Yes.
So, but the basic
Yes.
engineering is just around the basic engineering is just around the area of turning the shaft. But this shaft, we want to use magnet. So that returns down to getting a current carrying conductor, a set of coils, place it inside a magnetic field, as you know, rotative.
Yes. Yes.
Now,
That will
if you don't
cause.
want to do that, if you don't want to do that, you return back to the operation of motors. Yes. So you use typical motors, then do the type of thing, high pressured gas that will turn something that will turn the motor, either of the two ways.
Okay.
Does that make sense?
Yeah.
Yes.
Dr. Thank you very much. I think, okay, please let's take the last question so that we can go to the next section.
All right, thank you so much to moderator and presenter. I had a little tip of the presenter yesterday in our panel session, and I'm not surprised on what he's giving us today. Thank you so much, Dr. My question and request is I want to call your attention to my own area. I'm Dr. Elsie Akon, Associate Professor of Radiography. That's medical imaging. And we use very sophisticated machines, ranging from ultrasound to CT scan, MRI, and the rest of them. And those machines are energy sensitive. So in this part of the world, we suffer two problems. One, how to have the power. Without power, you cannot work. Two, the quality of the power that goes into the machine. Because all the failures of the machine from time to time is a function of the quality of power. Those machines are not just enough that the light has to be tested. So my question, I want to be scanning with a wristwatch that gives the power, steady power to the machine, so that when I take away my hand, it will go out and it will only come on when it comes. Since you say one can transmit, yes, on the latter note. So my piece is, please, how can we adapt this AI-powered energy modulation into these machines such that we can have low-cost power supply and then steady power supply in this our environment. Thank you.
Yes, that's a very nice question. But if you return back to what I showed about the microwave, there is no LLM inside the microwave. It is outside. Yeah. Take the picture of the food, send it out, it gets analyzed, returns it back. So the information is what it returns back before the microwave starts. Does that make sense? Now, in your own case, I think you asked a couple of questions. Number one is about the efficiency and the quality of the energy that we use in these machines. Number one, you have to get the energy, which you can also get from, we have in the sun. So we can use sunlight to generate some of this energy. Then the other one is about storage. And then we can explore different types of storage. Now, in terms of integrating AI, this is where it becomes sensitive because we are dealing with medical data. And these are not the things that we can really send outside to be analyzed by LLM because it's going to be database. What can happen is some of the engineering students here will know about. You can use things like basic microcontrollers, program simple machine learning algorithms to interpret your images at the edge with something like tiny ML. The engineering students will understand what I'm talking about, the computer scientists. So this, you can do those ones in-house. This is a simple project that you can give to, and then somebody will supervise that. And then they scan that, or they use that to interpret your images, tell the information back to whoever that wants it. And then you that is an expert will now compare based on knowledge. Does this make sense? Because yes, you train the model, and then it's giving you some, then you write your ROCs and all of that. But the result that it gives to you, does it truly make sense? So, and that's where you as an expert comes in. So, you see, it's possible there are different, so many things you've asked, but each of them has, possibility and what we can do. So we can collaborate on it and then work out something. Yes?
Yeah, thank you very much. It's been a rewarding session. And then, Dr. Arnold, you are so wonderful and awesome. Thank you. And let me invite the conference manager. Thank you so much, Prof. We appreciate you, Prof. Thank you for the questions you answered. Thank you. We are moving over to our current session. And the next to give us the talk is Harish Vanderville. I don't know if he's online. Could you spotlight him? Harish Vanderville. Harish, are you online? I don't know if we can confirm if he's online so that we can spotlight him.
He's not online.
It's not online?
It's not online. It's not.
Okay, it's not. Okay, so I think we'll move over to our next speaker. That's Dr. Reina. I guess she's online. Can you confirm Dr. Urena is online?
Yes.
Okay. Can you spotlight Dr. Urena so that I can read her short bio? Okay. Dr. Urena Onyewuchi is an accomplished engineer, global energy executive, and educational advocate who serves as the Chief Executive Officer of Ahiaise Solutions Incorporated, USA. I am early passion to solve infrastructure and electricity access challenges in Africa. She has built over 2 decades of technical and corporate expertise, spanning digital signal processing, power asset management, and smart grid technology. She holds a Bachelor of Science in Electrical Engineering from George Mason University, followed by both a Master of Science and a Doctor of Philosophy in Electrical Engineering from the Georgia Institute of Technology, where her doctoral research specialized in the asset management of complex electrical power systems. Throughout her distinguished career, Dr. Onyewuchi has held high-level technical and leadership roles across major defense, aerospace, and industrial corporations, including serving as lead switch and ancillary engineer for Orbital Sciences Corporation, data analyst for Western Geoco and Schlumberger, and division energy manager alongside senior electrical engineer for Corning Incorporated. Beyond her corporate and consulting leadership at Aneru Solutions, Dr. Onyewuchi is a highly influential figure in international engineering governance and social economic development. She's the founder and director of the A Professional African Platform, an innovative educational initiative that empowers learners across the continent through targeted professional development, short courses, and academic sponsorship. A champion for workforce development, diversity in STEM, and green modernization. She has served as the Power Africa Initiative Leader for the Institute of Electrical and Electronics Engineering, Power and Energy Society, coordinating international teams of experts to deploy sustainable energy solutions across African nations. Her extensive academic and industry contributions have been recognized with numerous global distinctions, including being named one of the Africa's 100 extraordinary women. Please clap for her, it's not easy. Pride Magazine's Woman of the Month, and selected for the prestigious Georgia Tech Alumni 40 Under 40. Please, with a warm welcome, let us. Okay, yes. You're welcome, Dr. Reina. Over to you.
Thank you so much for that kind introduction. I feel very privileged to be here today. Even though I've lived in the US for a very long time, longer than I've lived in Nigeria, but Nigeria is home, and I'm very grateful to be in this session today. So just to jump in because of time, I'm going to be speaking on the impact of power access, affordability, and quality on healthcare. So using my expertise in power quality and in energy management to look at or spotlight healthcare. And I'm going to be using a trauma center in Nigeria as a case study. I believe you can hear me. So I'm going to start by giving a little bit of statistics on power availability in Nigeria. And I want to say that you can only fix what you know. So if you don't monitor something, if you don't have data on something, it's very hard for you to fix it. And so that's something we have to look at in the energy field within healthcare. So right now in Nigeria, the generator is the grid. Here in the US, we have pretty much 24/7 supply of power. And those who have generators, which is mostly industrial customers, do that not because there's no power, but because of any little changes in their load and so on. But when you have the generator, diesel generator for that matter, as a grid, that's something that is of concern. So Nigerian hospitals do not supplement the grid with generators like most countries and continents do. The generators are the primary source, while the grid is supplement. For a country that has over 220 million people, our grid capacity right now is around 5 gigawatts, so 5,000 megawatts. This is something that's supposed to be about 100,000 megawatts. So we are backwards a factor of about 20, which is not good at all. It's a huge gap that needs to be filled. We have daily outages between 8 and 20 hours in major cities, and other places, including rural areas, even less than that, or even more than that. Generator runtime can be 12 hours a day. And according to research, over 50% of Nigerian hospitals lack stable electricity. It could potentially be more in some hospitals. So we have 4 cascading failures. We have an access problem, we have an affordability problem, we have a comfort problem, and we have a power quality and reliability problem. For access, we already said the grid connections for hospitals do not or deliver intermittent power. Grid is not the primary supply. Here in the US, in the utility space, we have hospitals and a number of other types of organizations listed as priority customers, so that if any kind of load shedding, which barely ever happens, if it should happen, the hospitals are still kept safe, because we know that there are too many things going on there that we should allow power to fail in any way. We have an affordability problem. So if you have diesel generators running more than 12 hours a day at a massive cost, and I'll talk about that in a few slides, energy spend is way over 35% of hospital operating budget in Nigeria versus 3 to 5% in the US. So you have in the developed nations, as they call them, you have a lot of money, a lot of resources left for many things. Energy is only 3 to 5%. Then in Nigeria, where we don't have things working, where we should be spending even less on energy, we're spending up to even 10 times more than what we're spending in the US. Then we talk about comfort. There's no central cooling in most hospitals. Operating room temperatures reach 35 to 38 degrees. This compromises sterile conditions, staff performance, and even patient recovery. Then for power quality and reliability, when we keep switching from generator to grid, this can lead to voltage sags. And I'll talk about voltage sags a little bit in a couple of slides. It could lead to transients. It could lead to frequency drift. All of these things will affect and negatively affect and destroy equipment like C-arms and power packs. So what can equipment tolerate, and what does Nigeria deliver? Before I come back to this simpler slide, there's a curve called the ITIC curve, the Information Technology Industry Council curve, which defines the voltage time envelope within which equipment must operate safely. Outside of it, equipment can trip, data can be lost, and surgery will be interrupted. So this is what the ITIC curve actually looks like. On the vertical axis, you have percentage of nominal voltage, and on the horizontal axis, you have duration in cycle. So if an event were to happen in here, so let's say that it's 1 millisecond, very, very short event, and 140%. So instead of 230 volts, let's just say it's about 280 volts coming into the system or into the hospital distribution system. Because it falls within these two curves, it's a safe region. It's a good tolerance region. The equipment is going to act like it didn't even stop 10 seconds, and you have 40% of nominal voltage, which let's say is about 100 volts. The equipment is not going to see it, but it's called a no damage region, but the equipment could trip or go offline. Now you have the prohibited region, which is up here. So even if it's as short as 10 cycles, or even as short as 0.5 seconds, half a second, if it goes to about 200%, so that's about 480 volts, for that short amount of time, you can fry or destroy the equipment completely. And that's what is simplified in this curve, in this diagram here, even though it doesn't show perfectly the two curves. So as mentioned, when you start up a generator, transients can happen. Frequency that's supposed to be 50 hertz is going to be between 48 and 52 hertz. It might look like a small number, but it's very dangerous for equipment. C-arms, which I don't have a picture of it here, but it's an equipment that's used for surgery, very, very important. It exceeds, when you have all these events taking place, the SAGs and the transients, the C-arms will exceed the safe envelope daily. And you have the UPS as the only protection to any kind of variation or fluctuations in voltage or frequency. So when we talk about the best practices for energy efficiency in healthcare facilities in the US, it typically boils down to lighting, HVAC or cooling, so air conditioner, diagnostic equipment, backup power, metering, and energy percentage of budget. So here, for most buildings, when we want to make it more energy efficient, we change the lighting to LED lighting. It can drastically reduce the energy spent on lighting specifically. So in the US here, you can have 40 to 70% energy savings. But in Nigeria, we don't even have as much supply of electricity for the lighting to be a problem. Yet there's still an opportunity there. By converting the lighting to LEDs, we are still able to reduce energy, the demand that's on the diesel generator. So that's something to consider. Then when we talk about cooling, here in the US, we have central HVAC with DDC. So, and programmable thermostats. So you have a big equipment or unit somewhere that's blowing air into the entire building. Now, we don't have that in most locations in Nigeria, which actually can be a good thing because the central AC can be a lot more expensive than if we have a non-central cooling. So one solution to that, which I'll talk about, is using inverter ACs to cool spaces at a time instead of the whole building at the same time. So we don't have enough duct work in most parts of, or in most Nigerian hospitals. Then you have diagnostic equipment. You have separate high efficiency cooling for CT and MRI rooms. Why is this important? Some of these pieces of equipment heat up very, very easily. So if they're to heat up too much, what can happen is that the equipment that's supposed to last maybe 15 years will end up lasting 3 to 5 years. And again, think about the affordability point of view. If you have a hospital that's barely making it and maybe charging just enough to break even or to cover the expenses in the hospital, then you can imagine how, if you're spending so much on HVAC, how much that can really, really affect the hospital and the affordability of healthcare. So for backup power, same as in Nigeria, we use UPSs for uninterruptible power supplies for critical loads because they can condition the power. So if there are any kinds of fluctuations in voltage, the UPS will absorb it and still send very good power or electricity to the equipment. Again, we're not just talking here about the ability of the equipment to stay up and running for 24 hours every day or 12 hours every day. We want to make sure that it's clean, good power quality so that the equipment can last longer. So it shifts from an energy affordability or availability problem to an assets management problem. Then metering. We have to make metering and monitoring a best practice in Nigeria, because like I said, when I started this presentation, if you do not know what you're spending, if you don't know how much energy you're using, you can't fix it. We talked about the energy percentage of budget. Again, affordability is a big deal. So I'm just going to give an example, and this is the data that we used and calculated. Part of me hopes that the numbers are a little bit skewed in the wrong direction, because if this is what is the case in some hospitals in Nigeria, we have a lot of ground to cover. So in this particular hospital, you have a staggering monthly bill. So we have about 3 generators that we're going to look at. One is a large diesel generator at 550 kVA, and then 2 other generators at 110 kVA and 100 kVA. So we have about 80 liters per hour for the 550 kVA generator. And then we have about 110 kVA generator at 10 liters per hour. And then another 10 liters per hour for the 100 kVA generator. So if we're looking at 24-hour supply, which is not, we have that the math comes out to, for all three generators, about 70 million naira spent a month only on diesel generators. So let's assume that this is for 24-hour supply and that instead we should use a 12-hour supply. So that will be about 36 million naira being spent in the hospital, or about 26,000 US dollars a month. This is absolutely unacceptable. We have to look for ways to shave this off and to begin to move that energy spend from diesel generators to other types of generation, and also reduce the energy used per month to something that is a lot more affordable. So I'm going to quickly go through this slide. It's an affordability chain. If we cannot afford the energy, if the hospitals are barely able to afford energy spend it's going to be impossible for the patients to afford, because they have to shift the costs back to the customer. So we have an unreliable grid, meaning that we depend on diesel, which increases or makes the hospital OPEX very high and inflates patient fees. So we have reduced access to healthcare. Without healthcare, mortality rate is going to continue to increase, and that's a problem. So we talked about the UPS being the only thing between the surgeon and the power failure. C-arm machines cost between $150,000 and $400,000. Okay, so if it's a refurbished one, it's between $40,000 and $100,000. A 5-year cost of ownership is over $95,000. That's for a refurbished C-arm. So if we have a brand new C-arm, it's way more expensive. As I already talked about the ITEC curve, some of these over voltages or voltages that are too high, even for short durations of time, can greatly damage these C-arms, which means that every 2 years, some hospitals might be spending upwards of $150,000 on replacing these pieces of equipment. So no cooling, I already talked about this. We don't have to do the central cooling like it's done in the US. We can use something like inverter technology to heat or to cool rooms separately and save on cost. So here are some solutions how we save money on diesel generator. So the inverter mini split AC, sub-metering for each generator so that we can begin to see what loads take the most use up the most electricity or causes the most cost. With LED lighting, we can even reduce how much is spent per ward from around $500 to $2,000 from what it currently is. We have to look at hybrid solutions, like maybe using solar PVs with generators or solar PVs with battery energy storage, and so on and so forth. So here is just an image of what an inverter AC looks like. And I'm just trying to go a little bit quickly for the sake of time. So what the data shows about power and patient outcomes, we're looking at equipment failure and power quality. By having an energy or electricity coming at the right quality of power, we're able to reduce the number of failures of equipment and even replacements of batteries in the UPSs. There's financial burden that we need to move away from the customer so that healthcare becomes a lot more affordable. For mortality and power outages, if we don't have constant supply of electricity, there will be failures of refrigeration, which will affect vaccines, blood products, and medications. So here is, and I won't go into this, unfortunately, but we're looking at about 3 phases of moving away from dependence on diesel to something that's more affordable. So you have the phase 1, that is immediate changes within 0 to 6 months. We have phase 2, that's near term within 6 to 18 months. And phase 3, long term within 18 and 36 months. So within 3 years, we're able to go through a cycle to greatly increase or improve energy efficiency in hospitals. The key takeaways we've talked about already. So I'm just going to move on to what are the next steps. We have shared that one of the things I do is professional development of professionals. What kinds of courses should hospital staff as well as doctors be looking at, or managers of hospitals be looking at, in order to save money and to drive things forward? We need creativity and innovation mindsets. I have offer courses in the areas that are listed that can help with energy management in hospitals. We have leadership and management courses, data analytics, entrepreneurship, and even project management. So I invite everyone here to participate in a hackathon that's coming up. If you have solutions in energy or in power quality for the healthcare industry, I invite you to join us for the global hackathon that we're going to have in October. I've included an email address here that you can go ahead and contact for more information on a competition to save energy in hospitals. And to conclude, you can contact me on the email address that is shown here and subscribe to the newsletters that I send out using the QR code that's shown on the screen. But I thank you so much again for this opportunity to present to you on power quality and energy management for the healthcare industry in Nigeria. Thank you so much. Yes, Professor Kennedy.
These are even declared.
Okay.
Than this.
All right. Can you hear me?
Yes,
Hello,
we can hear you.
Urena, thank you so much for this presentation. What inspires me about you is your passion and demonstration that you show towards Nigeria and Africa as a whole. Thank you so much, Urena. You've done it once again.
Thank you.
So
Thank you.
I'd like to say that power supply and electricity remain of significant concerns in Nigeria. However, as you have highlighted, these challenges are not unsurmountable. With innovation, collaboration, and sustained commitment from all stakeholders in Nigeria, there's a reason for everyone to believe and believe that this can be achieved. So on this note, I was asked to
for that talk.
can you hear me? Okay.
We
I was
want
asked to
see
take the questions and
Harriet
answers. Yeah.
has come online. If it hasn't, we can now move on to the question and answer session. Please, can you check if Dr. Harriet is now with us?
He hasn't joined.
Not yet. Okay, so we'll move on to the question and answer session. So to anchor this session, I'll invite Dr. Chinelo to anchor this session. Dr. Chinelo, are you online? Can you hear us? Can you unmute yourself, Dr. Chinelo?
Hello, can you hear me?
Yes, we can hear you.
Okay, so I've been speaking before. Sorry. Yeah.
Anchor this session.
Okay. So as I was saying, we thank Uredna for her excellent presentation, and she's been such a source of inspiration to a lot of Nigerians and the youths. And like I said earlier, power supply and electricity remain of significant concern to Nigeria. And as she has highlighted, the challenges are much, but they are not unsurmountable. With innovation, collaboration, and commitment, I believe all stakeholders can achieve this. On that note, I'd say that the floor is now open for questions and answers and comments from everyone, both online and offline. We welcome your contributions, we welcome your questions, and you are open to share your thoughts at the moment. So the floor is open, ladies and gentlemen.
Say, Professor Kennedy, your hand is raised. Go ahead and
Yeah, hello, can you hear me, please?
Yes, we can hear you.
Okay. Oh, great. Yeah, good morning, good afternoon, good evening, everyone, depending on where you are. I'm here at Parkland, somewhere in southeastern England. I have a project I'm trying to sort out with Toyota. I listened keenly to Dr. Rena's presentation. So I'll start by saying, Dr. Rena, thank you very much. You've been a great, friend, and I've really appreciated the kind of things you've been doing within the space of power systems. The presentation you made just now is at the heart of a conversation we're having with the Nigerian government and how we can, build reliable power infrastructure. I want to raise three major points. Number one, how do you think we can establish a solid working relationship with the Nigerian government, especially with the new thinking around smart grid infrastructure? The government have lots of plan, in rehabilitating some of their tertiary hospitals, and then power is a major conversation we're having at this point. Um, how do you think we can enact a working relationship that will produce tangible outcome? I mean, we've had lots of conversation in the past, and some of them, they've messed up, and we didn't get something reasonable out of it. So, from your own space, from your experience, how do you think we can engage you, and how do you think we can work together and see, how we can bring some of this thinking to, the Nigerian space, and then solve some of the recurring problems we've seen in the space, especially within the tertiary hospital. That's a very serious concern to us. That's number one question I have for you. Number two, the courses you highlighted, are they open source courseware, or what's the subscription model like? Can the university, subscribe for these models, and then I'll get our students into it. I want you to talk a little bit about, the cost distribution and how people can benefit, especially those that have interest in analytics, and project management, and some of those elements you highlighted. That's the second question. And then the final one, what's the availability in terms of mentorship of young Nigerian students? I heard you mention hackathon. I want you to talk a bit about the hackathon and what are the components or ingredients, because we have lots of universities within the southeast region. I mean, the 6 regions that we can get on board to participate. So if you can talk a little more on that plan, that would be very useful as we engage further. Thank you very much.
Thank you, Professor Kennedy. You're definitely an inspiration to a lot of us on the call, and definitely including me as well, all the research that you've been doing and the papers that you've been presenting. So thank you so much for your questions. So a solid working relationship, I think that what we typically do is to do a pilot first to convince the party or the government that this is something that can work. We do that sometimes here, not just in healthcare, but in industry in general. Especially when you have a high upfront cost. So sometimes the cost of a solution will make sense from a long-term point of view, but let's say your return of investment comes in at 4 years or 5 years. Some people in leadership might not get interested because they'll say, well, I don't know how long I'm going to be here in leadership. But if we can figure out if we can work out a way to show them that long term is still more sustainable and will create a legacy for the current leadership, then we're able to move forward. So, so I would say that selecting a pilot that makes sense, a hospital that's very important in the society, whatever state we're talking about. If we're looking at the state level, being able to show them, okay, this is an evaluation period. So, like with the work I'm doing right now, I'm developing a power quality program, and we are trying to determine which equipment do we want to utilize going forward. So instead of just jumping and picking a random pieces of equipment for the work, we're doing an evaluation phase. So we're going to select different types of materials or different types of equipment and install them at strategic locations, and then see over 1 year how they will perform. So that's the value of a pilot, is that you don't have to commit completely. You can do a little bit of test work on something, whether it's the main building of a hospital or a couple of theaters, whatever. So we just select strategically select a location and then go forward. And it has to be a constant conversation with the government, a lot of communication, so that it's transparent and they still feel like they have some kind of control. I think that that will be very helpful. Then the coursework, I would love to say that it were open source, but it's not. What you find that a lot of times for the types of coursework that is high, not high accuracy now, but that is substantially, let me say premier or premium coursework. It's not that cheap, but it's still affordable. So I've been able to negotiate with the designers of the coursework to make it for a special rate, basically for the African market. So by working with me, we're able to do that. What's the model? People can on their own take the courses themselves and make it self-paced, which is where what I would advise is to do an audio enabled one so that it's faster when you're listening to the educational material versus just reading it by yourself. That's what I do when I study. But we also have cohorts. If there are, let's just say, 5 students in the uni, or if there are 5 hospital staff members that want to take the courses, we can do it as a cohort and study it all together and complete it so that each person gets their own certificate of completion and can stand on their own feet when it comes to explaining what they've just studied. Then finally, you talked about mentorship. It is very, very important. And as you know, you yourself, you're a very good mentor. There are different ways. I have a very wide network of people who would be very happy to mentor. So it's something that we can talk about. How do we create something that is that we can do going forward? The number of mentors that are needed, the number of mentees, number of people who need to be mentored, and then we can create a program out of that we can now look at over time and see what needs to be improved or what needs to be done. But thank you so much for your questions.
Thank you so much. Probably just to wrap up, I missed Dr. Kelvin's presentation. We probably might have another session with you with the Center for Future Technologies. There's a current project we're having with the federal government on what we call Diaspora Bridge. I think I mentioned this, to you some time ago. Some of these things you highlighted, I think we probably might need to package it better and have a very deep conversation with Tet Fund and the Minister for Education, because these are things we need to really fast pace and get us to where we want to be. So thank you so much. Thank you so much. Our team will definitely come back to you, and then we'll advance this forward. Thank you so much.
Thank you. And I just wanted to conclude the hackathon. If you can register and we'll get back to you. So it's hackathon.aneru.com. So hackathon.aneru.com. So once you register, I'll be able to follow up with you. Thank you so much.
Brilliant. Back to you, MC. Thank you.
Thank you so much, Prof. Kennedy. So we had Osaru Osahon, Okoro Osahon, but I think his hand is down. So we'll take Abiola's question. Abiola Owosibe. She said on the chat, do you consider the effects of greenhouse gases from generators on the environment as effects of the emissions of greenhouse gases on our environment here from generators?
Of course, that's very, very important. We have models that we can use to estimate how much greenhouse gases are going into the air from diesel generators. So when we make the case for new types of technology like solar and battery energy storage systems, we are able to show that, look at how much greenhouse gases we're reducing or saving. And I think Nigeria is beginning to do this a little bit, but credits, clean energy credits, so that if you were to switch from generators to cleaner energy, you're able to do credits as well. So yes, that's very important, and we consider that.
Okay. Maybe I'll find out on this credit aspect of it from you maybe later on, so that I don't waste time. So any other questions, both online and on ground? Are there any other questions, please?
Is there any questions for her?
Dr. Angela, Dr. Adora, Angel.
Any questions? Oh, okay, we don't have any questions here.
Thank you so
Dr.
much.
Reina.
Thank you so
Dr.
much.
Chinelo. Thank you so
Thank
much.
you, everyone.
Thank you. Please, a round of applause. Okay, so this marks the end of this session because we couldn't get Parish, so we might not have his presentation. So what we have now is tea break. But before we go for tea break, I want to announce our breakout session rooms where we'll converge after the tea break to continue with our presentations. So let me make that announcement before we go for our tea break. So for track 1, which is Allied Health Sciences and Clinical Innovation, we have 2 breakout rooms. For room A, you use the VC's former conference hall 1. Then for room B, we use the VC's conference hall 2. Then the track chairs are Dr. Victor Ape and Dr. Anthony Ukafo. Then for track 2, which is the Mechatronics, Robotics, and Intelligence System, we're using this main hall. So please, after the tea break, those in track 2 should remain here. And the track chair and co-chair are Profina Fikwe and Dr. Akintayo Ojo. Then for track 3, which is Advanced Engineering Sciences and Smart Systems, you're using the Therapy Phantom Lab. And the track chair is Dr. Titus Chinebu and co-chair is Dr. Ijoma Oksuru. Then for track 4, Sustainable Technologies and Green Health Systems, you're also going to remain here. So you use the main hall here. And the chair and co-chair is Prof. Chika Wemena and Dr. Obi Naukeke as co-chair. Then for the last track, which is track 5, Arts, Creativity, and Human-Centered Innovation, you also remain here. So you have your own track here. And the chair is Professor Joshua Mwalo, co-chair Okoro Osaze. So please, the tea break is just for 5 minutes and we'll break out into our different sessions. Thank you very much. Please, for our own participants, we are moving to our breakout sessions. After the tea break, just 5 minutes for the tea break, then we'll break out. Thank you very much.
How are you? I just need to send you. If I'm going to have a session, but just come around. You understand? You're not want to marry.
Please, hello, everyone. Please, hello. Please, after the breakout sessions, we converge here for the closing ceremony. Please, we'll converge here after the breakout sessions for the closing ceremony. So please don't go. Come back here for the closing ceremony. Thank you.
Yes, sir.
That's
Okay, okay, yeah.
Excel. You can buy daily data for Excel. That's 24 hours it must finish. Like I buy it on shelf. It's yours. Wallpaper.
Email, okay. I don't have access to email. Let me try. Okay.
You make me want to dey cry here, and you let me thank you for me good. I cannot discard my hand, but I never need to come my hand. Things that don't enter my hand, people that don't enter my hand. I won't go for it again. They do me say I did for times. Oh, I will soon be back. Nothing here, no, will be fine.
Running ball है सामान कौन आलम सुन का फोन है वो सामान आज ओ yes
Take Wi-Fi to me. Correct.
You see this? That's how this. Very fine. You are doing better. Yes, yes. Abi? Bàbá náà kò bí ẹ̀rẹ̀ kan ní tó ń fi lẹ́tọ̀ yẹn wọ́n fi lẹ́tọ̀ ń máa rí lọ́pẹ̀ àwọn adélànà tá a wá rí ẹrù. Bọ̀tẹ́sán lè ní ó wà ìmọ̀ ìfẹ́ ìgbà lọ́nà ní ṣe o. Èdè yìí wọ́n máa ń rí lédè àwọn òdìbò àwọn ẹ̀mí ẹ̀rọ. Ṣùgbọ́n náà from US yẹn àwọn òdìbò òdìbò. Nípa tí àwọn ọmọ yẹn ọ̀rọ̀ kò ní ṣe UTC nígbà tó fún ọ yẹn. Àwọn ọmọ àti ọkùnrin wọn máa ń sọ wọn ń gbé. So office rẹ̀ ní ìdùn. Office náà ní gbogbo ìdùn.
I need to activate or install another version. The difference is nothing
Hello? Can anyone hear me?
I can hear you, ma.
Can you all hear me?
I can hear you, ma.
Dr. Madonna, can you hear me?
Yes, ma. I can hear you.
Oh, beautiful, 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 beautiful. You're all gathered again for the technical section.
Okay.
Yeah. Ojo, are you around? Dr. Ojo, are you around?
Yes, Dr. Joe is there.
Oh, good. Dr. Joe, okay. Please go on. Go on and moderate this section. So let's start from the first paper that is there. Check this thing, the program, and call the first
Prof,
paper.
let's start with Prof, can we start with track two? Track two in that order.
Yes, that is a
Yes,
track
I
two
have
I'm
the
saying. That's a track two I'm saying. So start
okay.
with the track two, the first paper there for today.
Yeah, you know what I'm
Yeah, please call the first paper for today and let us start.
It's all right, Prof.
Thank you.
I just stop. You can just stop. Okay. All right, good morning to us all. So we are starting from students. For track two, we have please see that track two and you are here. Please, can we indicate
We have
track two?
paper 33, paper 33 first. So call paper 33. Paper ID 33.
Do online now. Do online. Yes.
Yes, I like.
Okay, let's start with pattern 3. Open the, let me see the list so that if 30 is all around, put the next person.
So you
We're online.
Is
30,
online.
are you online?
Can you share your screen, please?
Please share your screen.
Paper 33, if you're online, please share your screen, your presentation.
Yes.
Welcome you.
I don't
You
think
have
she's
5
on.
minutes for your presentation.
I
It's
don't think she's
online.
online.
33.
Call the next person.
He's sharing his screen, please.
Oh, okay.
Check them.
Okay, can you hear me?
Yes, we can
Please
hear
go ahead. You have just 5 minutes.
No, it's 10 minutes.
This is my research on
Prof, please, quick. I'm already myself.
This is my research on
Go ahead.
transformer-based topic classification using malaria-related tweets. Here we used disparate tweets from Nigerians to find malaria-related topics that we can classify them into different topics to see the discourse of public health in the environment. We also made a human annotated data set, which was the first of its kind because there was not one existing before of Nigerian-related tweets. Usually there are tweets for COVID-19 or influenza, but not for malaria. And malaria still poses a very large problem. We used SNS scrape to go through tweets in Nigeria, and we used the query which gets malaria tweets that have malaria in them that are in a certain geocode and certain range, while filtering out different hashtags and emojis so that the birth-based transformer model could more easily look and classify different topics. Overall, the performance was pretty good, but the thing had a problem with getting misinformation. Besides that, we could easily find when people are talking a lot about symptoms or sharing information about how to treat the malaria. The bird tweet, which is what we use, outperforms other classical models, that are used for classifying tweets. This can help the medical board to find trends that are happening online before they actually get to the people. Because people usually text about what's happening before it's recorded. And I actually hosted the app on Hugging Face. So yes.
Hello.
Hello, I'm done.
So are you done with your presentation?
Yes, yes.
It's all right. Oh.
Were you hearing me?
Yes,
Yes,
thank you. Thank you, Mr. Uguchukwu. Is that correct? Yes, yes.
Yes.
Just like.
Yeah. Should I stop
Please,
sharing?
can you please go back to the
Please go to your
first slide.
page, the first slide.
The first slide, please. Transformer based.
Okay, Mr. Uguchukwu has centered on transformer based classification of malaria-related tweaks in Nigeria for public health surveillance. Now, I don't know if you have any question for him or contribution. You can go ahead now. Is there anyone? All right. Thank you very much, Mr. Gochukwu. For this presentation. Please let me the next person. Now we can go to paper 66 now. 66. Are you here or you're online? 66. Paper 66. Paper 74. 74. You have a slide meeting here. Please move 5 4 to present. 74. Track 2. Go track 2.
74. Okay. Okay, yes, I was like. Full was paid. 74. 74. Is that? English students number. Where is the? This is the platform. 90 support now. You can have online now. I need go online. Strike has to go online now. Who's more than needs to go online?
Good day. Here to present our study on digital classification using machine learning and deep learning techniques, a cooperative and computational analysis. My name is Akoyoto Ogenekjore Emmanuel. My co-author is Ahiaise Conference.
Please come with me. Where is he coming? Come here, sir. I don't know. You need to have your seat. Sit here. All right. So that this online can see you. All right.
So, as I earlier said, my name is Apolito Ogenekjore Emmanuel, co-author in Ahiaise Conference. The background of the study is the application of these handwritten digits to financial processing, postal automation, and clinical documentation. And we have the challenge of high variability in handwriting and the knowledge gap that this study has to fill is that we have limited studies for performance and computational costs presently. So although CNN achieved near perfect accuracy They still need for structural comparison that evaluate both predictive performance and computational implications. Please go to slide. Slide 3, rather. Go to slide 3. Objective and contribution. This study compares logistic regression, random forest, and a deep learning architecture of CNN, that's convolutional neural network. The models we evaluated using accuracy, precision, recall, and F1 score, even confusion matrix, as you can see from the slide. Slide 3. Okay. So this contribution lies in 3 aspects: unified comparison framework, computational complexity analysis, and statistical validation, biomedical application relevance. This study, like I said, is find real-world application in biomedical relevance. Go to slide 4. Okay. Slide 4 is methodology. Okay. So the data set we use is the MS data set. As you can see it from the screen there, it comprises of 70,000 small square images. 60,000 was used for training, 10,000 were used for testing. And the models, like we said, the machine learning models are logistic regression and random forest, while the deep learning model is convolutional neural network, that is CNN. The architecture of the CNN can also be seen from there. It contains 2 convolution layers of 64 and 128 filters. Then we can see that the CNN model uses hierarchical feature extraction. We drop out regularization to improve generalization and prevent overfitting. Please, the next slide. The next slide is a comparison of model results. We can see from the bar chart there that the CNN achieved the highest result with 99.63%, while random forest and logistic regression achieved 96.8 and 92.23% respectively. This next slide. Conclusion. The CNN gave the best performance, but the trade-off is high computational cost, requires graphical processing units and advanced infrastructures. Practical relevance. The CNN is best used for large hospitals, radiology departments, AI-assisted diagnosis, while the random forest and logistic regression are best used for small hospitals and clinics and health centers. Future work will explore efficiency, optimization, lightweight architecture such as MobileNet, and it will explore vision transformer, real-time deployment, embedded system, and biomedical systems. This study highlights the trade-off between accuracy and computational cost, providing guidance for more data selection in real-world and biomedical applications. Hence, in hospital environment, high accuracy alone is not enough. The best model must also depend on available resources, urgency, explainability requirements. Therefore, the takeoff from this study is there is no single best fit model. Best choice model must depend on the context. Please, can you go back to the comparison of results? Just the next slide. Yeah. Okay. Click there. So I just want to show you how the code implementation of the results, if it can come up, of everything that we have been talking about. All right. It's coming up now, just a few seconds. It's taking time.
So it's all right. It's just going.
It's okay. So because of time, the it's coming up, but if we have the best, it's common. Nevertheless, so the best fit method or model cannot just be depend on accuracy alone. Must also take into account the context. Where are we? Are we using, is it in teaching hospital, healthcare center, or general hospital? So we must think of all these before we choose the best fit model. If we need fast result, we can use the logistic regression or the random forest. But the CNN is best fit for large hospital, as we have just said, like the teaching hospital, where we need high accuracy. Thank you. Thank you very much.
Thank you so much, Mr. Presenter. Please sit in case you have questions or contributions. Please, any question, contribution from what you have presented on machine learning and deep learning? And if you may ask, you integrated machine learning and deep learning, is that correct?
Yes.
And you concluded that there is no single best fit model. And the paramount thing is to actually put into consideration the context.
Exactly.
I don't think that's new anyway. When it comes to modeling, I think it's context we have to consider. So that is not new to me and I think to many people that are dealing with modeling here. But thank you so much. So why do you have to integrate? Why not machine learning alone? What do you want to achieve by integrating both machine learning and deep learning? Thank you.
Yeah, the main work here is not just integrate, it's cooperative study. Comparing three models and also taking into the computational complexity into account, even the statistical validation. So when using statistics, we found out that even the CNN also came at best. And most studies only concern on the deep learning or CNN. Most of them do not compare it with each other. But this study compares CNN, random forest, three models together. It's comparison, not integration.
Next time from your title, you clarify that it's not your title that I read now is not about comparison. For this conference paper, so we believe that in the subsequent presentations, there will be improvements. Okay. Further comments, suggestions, additions for our presenter. In the absence of none, please let's put our hands together for him as we talk about the seats. Now we have paper 89. Paper 89. A review of AI user adaptive modulation and integration of robust wireless patient monitoring. A comprehensive review. Okay, let's move to the next one. Okay, let me go. Okay, do you have anyone online?
Nobody.
Okay, there's a comment online. Is anyone talking from from your side?
Yes, sir. I think there's a question here.
The question, okay, for the last presenter, right?
Yes, from you have a question, please.
Have a question.
From Mr. Okoro. I'm currently experiencing a network issue, and I have had to relocate. So it's drizzling this morning. So I have been moving on field type, trying to find a signal to participate in the convo. Okay. My question is about your energy saving model for hospital or centralized system, where blowouts are used to circulate air through the building and regulate the cooling system. Is there any available data on user experience or feedback related to this model? That question is for you, sir.
Sir, the question. The
question is about energy saving model for hospital or centralized systems, where blowers are used to circulate air.
Sorry. The question was for Hello, the question was for Professor Ureni, the presenter before now. I just came online. Okay. It's not for this presenter, actually. I just dropped. I didn't want to interrupt anybody.
Okay, thank you. Thank you. It's not for the
I just dropped it so I can send to her. If she's here, she can reply. That's all.
Please kindly check the conference platform. I've shared that
I've not presented now. We have by the 74. Yeah, sorry. 74 are presented, right?
Yes, 74. Yes.
So we have 66. We have 89 that have not presented. Yes, 84. No, we are going to track 2. So for track 2, we also have 07, paper ID 07, paper ID 24, paper ID 24, check online, they're online. Paper ID 24, paper ID 7, paper ID 27, paper ID 38, and paper ID 52.
Who is Vera? You kindly mute your microphone, please. Mute your microphone.
Nobody. So I will go back before we go to track 3. I will read track 4. I will read the track 2 that are not yet presented. Paper ID 7, paper ID 24, paper ID 37, paper ID 38, paper ID 52. They have not presented. And for today's section, we've only had 2 presentations.
Okay,
we had paper 33 as presented. Paper ID 66 as not presented. Paper ID 74 as presented. And paper ID 89. Is 89 here? Is it? Okay, please. Now, please send your slide. You have your slide with you.
Send your slide.
Have you sent to him?
Please send.
So we have paper ID 89 now. 1, 2.
Sure, I had this time too. Or I had this time too. Much I don't know. So go to class. You need to represent both sides. So 3% the same. Church de deliver. Office cemetery. É para você se falar com ela, não é? Nada a ver. Não? Onda do lugar, vai ser. Sim. Good afternoon. It's no afternoon. Good afternoon, everybody. Good afternoon, panel of judges. Good afternoon, my colleagues. I'm here to present a review paper. My name is Jonathan Ogunaya. Yes, it's a review paper on the topic of my paper is a review paper on AI-based adaptive modulation and the modulation for robust wireless patient monitoring. Okay. 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 The proliferation of wireless body area network and the remote health monitoring system has fundamentally transformed healthcare delivery, enabling continuous surveillance of patients beyond the traditional clinic settings. What we are saying here is that we want to monitor the patients without being in the hospital, at their home, in their house, and monitor some of their physiological conditions. So, introduction, the landscape of healthcare delivery has undergone a profound transformation driven by advanced miniaturized sensing technologies, widespread wireless connectivities, and imperative for continuous patient monitoring beyond the hospital walls. Okay, wireless channels, wireless challenge, wireless challenge management. We have a body-centric propagation characteristics. We have qualities of service requirements, then interference and consistency challenge. Yes, like yes. The deep learning challenge for estimation of healthcare system. Under deep learning, we use neural-based challenge prediction, advanced architecture for dynamic environments, hybrid learning approach. Then adaptive population through machine learning. Through machine learning are done by reinforced learning for link adaptation, energy-aware modulation for adaptation for web wireless-based area network system, context-aware wireless intelligence, then classifications for intelligent receivers. We classify them based on this, that deep learning architecture for automatic modulation classification, that's AMC. This
This allows a cognitive receiver design essential for robust and efficient monitoring. Then the lightweight model for resource constrained devices. Computational restraints of large complex model affect wearable operations of a model. Computational constraints of large complex model affect wearable operations. Models must be lightweight. What we are saying here is that the operations of a lightweight, the model must be at least with a lightweight so that it will not affect the operations of all the wearable devices that we want to use. Then the next is the robust under low SNR conditions. That is low noise condition. There be no interference between signal, no response, signal to noise response condition. Then we use scale signal processing capable of accurate modulation under the noise channel, in which we're able to reduce the signal to noise ratio of the signal that we are transmitting. Intelligent challenge. So integration challenge and emerging solutions. So under this, we use hardware implementation considerations, and with security policy consideration, the next generation network integrations. Those are the challenges. The research gap, we got the process of the review and the unified optimizations, clinical validation requirements, emergence technology integration. Then in conclusion, the review has examined the transformative potential of artificial intelligence for adaptive modulations and the modulation of wireless patients monitoring system. Thank you. That is my...
Thank you, Mr. Presenter, for the wonderful presentation. A review of AI-based vaccine modulation and demodulation for robust wireless patient monitoring, a comprehensive review. Please, if you have any question for the presenter, let's indicate any contribution. Students, you have questions? Colleagues, please, if you have a question for the presenter, let's know. Okay, in the absence of no question, let's presenter go and take a seat. Thank you very much. Thank you. Let's put our hands together for the presenter. Thank you very much. Now, for track 2, at this time, 6 persons have not, or 6 papers have not been presented. Paper ID 66, paper ID 52, paper ID 38, paper ID 37, paper ID 24, and paper ID 7. If you can join us before the end of the second session, we still take them. So let's go to track 4 now. Let's check it.
Professor Chika, can you hear me?
Track 4 is online.
Yeah.
Before we continue.
Yeah. Thank you.
Thank you. It's online.
Okay.
Yes, you can go ahead. Thank you.
Thank you. Thank you, sir. Good morning, everyone. Please, can I know those in track 4 that have not yet presented? Can you hear me? Track 4 is sustainable technologies and green health systems. Can anyone hear me?
Yes, we can hear you very well.
Okay. Thank you. Because of what happened yesterday, I may not be able to know the exact people that have paper ID 4 presented. Paper ID 4, paper 39, 44,
47, 54, paper ID 55, 62, 70, paper ID 78. Is there any of these paper IDs that are yet to present? Okay, I think I'm getting some notifications on that. Thank you.
Oh, just give me some minutes.
Okay,
I'm trying
so
to.
paper ID 76, 84, 87. Okay, this is for track 5. I'm looking, let me get for track 4.
Yes, I'm coming. Oh, just give me some minutes.
Okay,
I'm checking for track
for
4,
track
track
4.
4.
Okay. But is there any?
Prof, actually, no. Actually, nobody is presenting today for track 4.
Okay.
So we have to go to day one. Parvention said they presented.
Yes,
Checking now to see.
it was really day one that I was calling out.
Okay.
I don't know if there's anyone from day one. The paper IDs that I've called, they were from day one.
Yes.
ID 55. Okay. Paper ID 55, 62, 78. Are they here? Have they not presented? 70 is also there.
Paper ID 55 presented yesterday.
Okay.
Yes, awesome. Yes, paper ID 62.
Has it been presented?
Yes. Paper ID 62 presented yesterday.
Okay. What of 70 and 78?
No, I don't think 70 presented yesterday. Paper 87, that is Dr. Chinelo. 70 is there?
70 presented. Please conclude that, please.
Please conclude that 78. 78 has not presented.
Yes.
Yes, okay, she presented yesterday.
Okay, what of 70? What of waste to energy innovation? Has it been presented?
Not at all.
How about 70?
70 has not presented. I think it's that's
Can we have
Dr.
them?
Madonna.
Only four yesterday.
We were just for.
Yes.
Can we have paper ID 70? Chinelo.
Dr. Madonna.
Yeah.
Dr. Madonna, are you here?
Michael Chukwuju.
55.
Paper ID 70.
Madam Buka has not.
Dr. Madonna is not.
62 has not.
I think is Chinelo not here?
I'm telling it now.
Okay, 55,
62.
Saying the auto tissue.
62.
That's okay.
70.
70 has not presented.
55,
62.
62 has not presented.
I've not presented.
Yeah, I presented.
Okay.
That was yesterday.
Yes.
Yeah.
No, nobody's presenting. No schedule for track 4. No schedule for
No, there is.
For track 4, no. There's no track. There's no schedule for track 4.
Let's go to our session yesterday. Session yesterday. Session yesterday.
No, just one session for track.
So that presented yesterday that we have my class. It was
I know that this two are not.
No.
Are you sure they want to?
Okay. Okay, it's really it's because they're putting one person now.
I think this is no. What happened when it's a little bit Asian?
Yeah.
That means they got
55 presented yesterday.
But she has not.
Yes, is she here now?
Yeah, she wants that. She should be.
Please call her.
Listen, let me check the other person.
Doctor, are you ready now?
This 70 has not presented.
Yes, I'm starting.
She's online.
So I was the one that joined online yesterday.
Okay. We're having issues.
She knows that not certain. Who are not certain. Hello, Prof. Can you hear me?
Very well.
Yes. As of now, two presenters are yet to present. That is paper ID 70 and paper ID 63.
Okay.
Paper ID 70 and paper
As-
ID 62.
So can
So
we have
I
any
sent the
of them?
screenshot to you. I don't know if you have checked it. You can check it what's first.
All right.
Paper ID 70 and paper ID 62. So these are the presenters that have gotten.
Okay, so is paper ID 62, the presenters, are they here? Biochemical and kinetic study of glucose oxidase. Are they here? Now, are they ready? They should please share their screen and start their presentation. Ozemena Eje et al.
Let me call.
Paper ID 62.
We should go to part 5.
Are they not here? Are they? Florence Ndoka is there. Ezike Tobechukwu, Ijeoma Okolo are they not here? We can move to 70 if they are not here.
Yes,
Or if paper
Dr.
ID. Pardon?
Yes, for paper ID 70, that's Dr. Chinelo. She's not
Are
here.
they here? Okay.
No, no, Prof.
Oh.
Prof, I think we need to proceed to track 5.
Okay.
So we can still come back to track 4, please.
Okay.
So let's call track 5. Track 5. The track share, please, are you ready? Prof.
No
We'll
problem.
come back to track.
Okay.
Thank you.
All right.
Okay, I think track 5. We have 3 papers in track 5. We have ID 76, Grace Okafor, Wisdom Okafor. Are you around? Track 5, ID 76. ID 76, are you around? If you are not around, let's go to ID 84.
Paper ID 84, yes, that's Professor Wike. Professor Wike. Prof. Yes, sir.
ID 84 is on health and transitional experiences. It's on health and transitional experiences. Organization. So let's talk about health and transitional experiences of civil service retirees in Ebonyi State, Nigeria. All of us who are public servants and civil servants will have hope of retiring. And then as we age, we want to be informed about the retirement challenges that we face as individuals. This paper is an empirical work conducted by Joshua Onweke and Nweke Ebereogin. And this study looked at health transitional experiences, those experiences that aged individuals present. You know, health peculiarities of the aged are usually distinct from others. They are distinct in the sense that it's not how they were presented at the time when they were young that you see them when they grow old. Most studies on retirees drew attention on basic welfare challenges that they face in terms of their feeding habits and other issues. But such challenges like good food, clothing, income, social integration, and others are the things they face. And also the health challenges they encounter in the light of recognized pensions available to them are often not addressed. Now we see that in Nigeria, for instance, where we experience the issue of contributory pensions, we discovered that the availability of these pensions is not forthcoming at the right time, even when individuals present themselves with health challenges. And there is need to look into these challenges and how to overcome them. Then the methodology, the design adopted for this study was a survey design, and questionnaire instrument was used to generate information. And we also used the in-depth interview to interrogate individuals who present themselves for this study. And this was complemented by in-depth interview. Now the study was carried out in Ebonyi State Ebonyi State, where we have estimate number of civil servants who retired. The total population of the study is 4,149, and the sample size was 400. Now, results shows that respondents consisted of 70.1% males and 29.9% females. And about 60.5% were between 58 and 77 years. This will tell you their retirement ages. And also we have 22.3% who were between 38 and 57 years. Then 15.6% were 78 years plus, while 1.6% were between 18 and 39 years. About 46.8 had their bachelor's degree, then 22.3 had higher education certificate or diploma, while 4.4% had no formal education. Now, on substantive issues, we discovered that most retirees could not keep their surroundings clean because they're already old. They can't sweep their surroundings, they can't even wash their clothes, and then they find it difficult to even cook food and eat. And most of them live in a dirty environment, and that's the position of 56.6%. The majority of the retirees lack the resources to attend to their health needs due to inadequate pensions. They can't go to hospital, they can't pay hospital bills, and it became a very big challenge. Now, poorly treated sicknesses such as high blood pressure, low blood pressure, diabetes, prostate cancer, pneumonia, and site-related ailments are common among retirees, and that goes to 97.7%. And some retirees have difficulty accessing medical care due to old age and lack of caregivers. because these people needed caregiver that was for them, that will do a lot of works for them, but they do not have. Now, the study recommends that retirees should enroll in health insurance schemes so as to give them access to treatment when they are sick. And also that caregivers should be provided for retirees, that is elderly, to assist them in meeting up their welfare needs. These are the recommendations we have for the study. Thank you. You may throw in your questions.
Thank you so much, Prof.
Yes.
For this wonderful presentation. Your recommendations are very good. This is a study that has the data above 1,000. So the result is highly reliable. Because if you are considering a state where you are already getting data for 1,005 retirees, so we can actually say that it has captured a good number of retirees in that state. Well done, sir. Now, my concern is on the recommendations. And these are the things we put there are the things we hear from Obodo from that we see that they do in the UK, the US, Canada, and other stuff like that. And to achieve this recommendation, what do you think we have to recommend to our government? You said we should give caregivers to our retirees. We should have a caregiver home. And culturally, we don't believe in those things. We don't do those things culturally as Black people. We have our own cultural way of handling our. And once you become too old in Africa or in Nigeria, they might even call you a witch. So we have our own cultural problem. What do you suggest? I mean, you have recommended now. What are the way forward? How do you think those recommendations can be achieved? Thank you.
Yes, when we talk about caregivers, we're not looking at those people that you keep in a place and provide for them. You who is retiring, in our culture, we have what we call people who are taking over from you. For instance, you have your grandchildren who are going to stay with you. Like if your father is still alive, your mother is still alive, you can also make provisions for a process whereby you can send your son or your daughter to live with them, to help them, because they also took care of you when you were also young. So your own children can also help to take care of your father and provide food for them and get them sustained. It's a cultural way of sustaining the aged. Because if you allow them to be in old people's home, some of them may feel isolated, but you have separated them from their children and they feel bad. And that is why even those who are grandparents, they feel more comfortable to be with their grandchildren more than even with you, who is their direct or biological child. So we can use it that way to solve the problem.
Thank you, Prof. Since Prof is the chair of track 5 and is more presenting, so let me moderate it. So, any other question, please? Okay.
Yeah, Prof, thank you for your presentation. My concern is, you said the population of the retirees is about, is it 4 million or thereabout?
1,400.
1,400, and the sample, the Jew is about 400.
400.
Is it a good representation of the population? That's one.
Yes, we use the Caro Yamini formula to determine it, which lands in 399.
Let me finish. First. Another question is concerning what Dr. Joe is about the recommendation. We are talking about the retirees enrolling in a healthcare whatever scheme or some sort of health scheme. Is it when they retire that they enroll? How do they go about that at that stage? at that age point in time when they are almost retired and all that. Let me know how that can be done. But thank you.
Yes, the population sample was determined using the Taro-Yamin formula, which lands us at 399, and we approximate to 400. So it's a statistical formula that we use to determine it. And also, when we talk about retirees enrolling in a health insurance, yes, even as retirees, you can, if you have not enrolled in health insurance before, you can still enroll in health insurance. At any point you want to do that, you can do it. And the people we studied are people who are not under contributory pension scheme. They are state government civil servants who retired. And in the state, they were never enrolled in the health insurance scheme. So it's a recommendation that even when government did not open up that channel for them to get enrolled, they themselves can also get enrolled. Their children can encourage them to get enrolled. You know, they pay stipend every month or every year to update their data so that when they are sick, they can go to hospital, no matter the fee, they will pay a certain percentage that will be less than the fee they could pay when they are to pay directly for the medical services they receive.
Thank you, sir, for the presentations. I have something to say about the recommendation. I'm of the opinion that before retirement, all establishments supposed to have a scheme for them and educate them before going for retirement. If there is education, if you educate them about what they are going to meet outside when they are no more in service, I believe they won't look so dirty. Their environment won't be dirty. They will know what and what. And we should even encourage them also to know how to keep themselves, how to manage the resources they have been given or the resources they have been saving. For example, a lot of retirees, they do not plan ahead. A lot of them do not have accommodation of their own. They are still in rented houses. And by the time they now, they are no more in the service, you discover that the money they were giving, a lot of them will now still be renting houses or start building a project. And retirement money is not meant for building projects. It's meant for their own maintenance. So I'm of the opinion that something like that should be incorporated into the scheme for them. And the issue of maybe grandchildren staying with them in this our own era is no longer obtainable. So what we can do is that insurance scheme you are talking about, they can be enrolled. There is something Lagos state governments are doing now that I was told of by my younger ones over there, that they are registering their elderly people for scheme like this, that they can be able to pay a stipend after, so that they can be well taken care of. Thank you.
Okay, thank you very much for your contributions, ma'am. So let's put our hands together for Prof. as a result in this evening.
Okay, thank you.
Now is there anyone in track 5 presenting now? So we start from track 2 again.
Yes.
And we go over from track 2 to track 4, called the child track for when after track 2. For track 2, I'll be inviting Dr. Oluyemi Matthew. Are you online?
Dr.
Find out
Oluyemi Matthew, can you hear?
Yes, sir.
Find out if paper 7 is online.
Yeah, it's online now.
We know. Track 70, paper 70, I know is online, but when we get to part 4,
well, let's
to present, please.
We are starting from
please.
track 2
now.
If he's online now, please call him.
The person I
He's
called
an
now is
Indian
online.
author. If he's online now, call him please to present.
The Indian author.
Oh, Indian author, okay. All right, let's, Dr. Martin, please look for him back. Let's invite for 70. Oh, sorry, by 70.
Paper 7. Paper 70.
I thought 70. 70.
Indian author.
Okay, paper ID 70.
Paper ID 70 is Chinelo Onwusi.
No, paper 7. 7.
7, not 70. Okay, why you will get it?
57. 57.
Not 57. 7. 7.
Paper ID 7.
I can't find the slide here. Where is the slide? Where is the slide?
Tell him to share his screen. Tell him to share his screen.
Oh, the person is not ready. Please, let's allow the person to present
now. Paper ID 7. Please share your screen.
Please, can we go back to track 2? I'm not sure.
Okay, it's not online. We have heard. So while waiting for him to join us online, let's take it. Let's go back to track 2 now. While waiting for paper ID 7 to join us.
Dr. Matthew Oluyemi, can you hear me? Please, if you are here, kindly please share your slides. And if you are finding it difficult, let me know so that I can share it from here. Dr. Matthew,
yes, sir.
Are you there?
Yes, I'm there. Please, can you help me share it from your hand?
It's all right.
Share your slides from this side.
It's all right. Just give me a minute, please.
All right, thank you.
Okay. Can you see your screen now?
Yes.
All right, please.
All right, yes.
10 minutes to present.
All right, thank you. So I will be presenting on results on convergence of one-step nonlinear rational integrator for solving ordinary differential equation by F. Eboime and M. Oluwayemi. Permit me to say that what we've done here is basically looking at a numerical solution to solve differential, a certain kind of differential equation. So the next slide will be the abstract of the work, which, of course, we looked at a scheme, a new scheme of using one-step nonlinear rational integrator for solving ordinary differential equation in this work. So, and we also consider the stability function for the method, and we also look at the convergence. We look at the region of absolute stability for the rational integrator. So, permit me to also mention that this is an ongoing work. So, input is permitted or is where necessary. Now, as we all know, as a way of introduction, various physical problem comes in form of differential differential equation, either partial or ordinary. So either you can have some natural science or life science problem, physical problem that comes in form of different form of differential equation. So in this work, we consider a stable solution of a non-linear one-step scheme using an interpolation function as equation 1, as slide 3. In slide 3, so equation 1 is given in form of differential equation. So
They say your job is perfect.
Yes.
That was why we finished just
Early. They asked me for
Mute them, please. They are distracting. I think that that's not enough.
Dr. Matthew, can you please proceed? Dr. Matthew, can you hear me? Dr. Matthew, we can't hear you. Can you please unmute your microphone?
Oh, sorry. Sorry, can you hear me?
Yes. Go ahead, please.
Sorry. So, like I said, equation 5 in slide 4 is of interest. So we have equation 5, and we say when m equals to 2, we have the next equation where P0, P1, and Q3 are called integrator parameters. Then we look at the definition of the method of interest. So for yn equals 1, we have that equation, and in between we have made some calculation forming the required to this form, which gives equal 12. So which was solved using we apply Kramer's rule. Some Q1 and Q2. So Q1 is even as Q1 equals to xi over value of a, the determinant of a. So that was solved. Then we have the a as given by next equation, and we have our yn plus 1 as the as that parameter, as that's rational function. That's the next slide now. The next slide. Next slide. So we have our yes. So that's our rational function. Now, so we have so this is our rational function of interest, which was solved. So our concern here is the application of this new integrative factor in solving a number of problems. So which, as we consider it in the work. So the integrator was designed or is designed as to determine the convergence, consistence, and compositional stability of the method.
He's not. I mean the power forms
of the method of interest. So then we look at, we consider a number of, so we consider a number of, in particular, I think we consider 4 using the method. So we consider 4 types of problems. The next slide. So with equation and we discovered that this method is faster, is easier, is at least more accurate compared to some of the existing problems. So in particular, so we solve 2 major problems using different methods, and those are the problems. Next slide.
Okay.
So next slide. So next slide. Next slide. So yes, so those are the 2. So we consider before this, please. That's some solved problems. So we have some solved problems. So those are the 2 problems we solved, and we looked at those problems comparing the result with some existing results. So the new scheme or the new integrator was compared with various results, as we said, using different methods like approximation, block hybrid, and trapezoidal multiple step method of second kind, which was used in 12. And we realized that this new result seems faster and more accurate compared to that result. Now, in conclusion, so the use numerical methods in solving this initial value problem demonstrate more accuracy and is convergent. Then we also look at the absolute, or permit me, I didn't show the radius of absolute stability. I mean the graph, the figure in this work. So, but it shows that the entire left hand of the complex plane and the space outside the diagram. So we also factor out the stability region of the work, and we discovered that this method seems easier and avoid the stress of introducing integrating formula in solving this kind of problem, which of course is one of the advantages it has over existing problems. Okay, so limitation and applications. So the study, so the next line, sir. So the limitation and application. So the study does not consider specific application of the scheme in terms of to light problem, but was used to solve some differential ordinary equation.
Dr. Matthew, can you please? Hello.
Yes,
Dr. Matthew, please. Kindly please conclude. You have 1 minute left. 1 minute, please.
All right. So such equation has applications mentioned here. So thank you. So these are the references. So thank you.
Thank you for your presentation.
Thank you, presenter. Please, is there any comments? Any comments? Or any question that need clarification from you? No comments. No question. Okay, thank you.
All right.
Any
Thank you,
other
sir.
question?
Dr. Madonna, are you there? Hello, Dr. Madonna. Dr. Chinelo.
I'm here.
Dr. Chinelo.
I'm here.
Are you
hear me?
ready to present your paper?
Yes, I am, sure.
Yes. All right.
So just give me some minutes. Let me set up this. Yeah. Where's my slide?
So let me download that slide. Dr. Chinelo and Madonna. Slide 7. Do this track this thing. Track 7. Is it there? Is it online now?
I've sent you the intern guy. He's online.
Are you sure he's online? What's his name? I can't see him online. Let's call him track 7. Track 7, paper ID 7. Are you there? Paper ID 7.
What's his name? Somebody crashed.
Paper ID 7. Please, if you are there, kindly please unmute your microphone. Paper ID 7.
It's not there. So I told you. It's not there.
Now let's go to paper ID 70 now. Paper ID 70. Dr. Madonna, Dr. Chinelo.
Yeah, please just give me some minutes. I'm trying to lift out the slide. Okay, let me use this. Okay, thank you. Should I share my screen?
Should I share your screen? Thank you.
Thank you very much.
Yes.
Where's the share button? So, I have to dig out that stuff now.
I can't
Download.
start your video. Would like to see your face.
Okay, fine. Download paper ID 70. Okay. Okay. Are you seeing the screen? I want to know because I have 3 screens. So I want to know if you are seeing mine, on which screen it is. Are you seeing the screen, please?
No.
Are you seeing it now? Okay.
Yes. It's
Okay.
coming up.
Okay. So can you see it now?
Yes.
Sorry for the delay. Okay, and then my video. Is my video up? Let me check it. Okay.
You have 5 minutes.
Okay, whatever. Thank you so much. Can you see me now too?
Yes,
okay,
we can see you.
So let me start from slide 1. What is the current slide? Oh shit. Slideshow. Thank you. From beginning. Yeah. All right. Yeah. So thank you so much for this opportunity. This. Sure. Sir, please, you have to give me 1 minute. I don't know what's. Or can you manage it to half slide? Can you manage it like this? Or maybe if you can, I should forward it to you.
Yes.
It's on track 2.
Yes,
I dropped it on track 2.
Track 2. Okay, let me check. Track 2.
1 minute.
Track 2. Okay.
For the paper 7.
Please, she's ready. She's ready. Opportunity is ready. Let me just download that paper. She's here already, so we have to. No, I'm going to share from here. Doctor, so I'm going to share the screen. You can stop sharing over there. I'm going to share from here. Dr. Chinelo, can you hear me? Please stop sharing the screen. Dr. Chinelo, I hope you can hear me, Claire.
Hello, can you hear me?
Very well. Can you hear me clearly?
Yes, I can't see your slide though. Maybe if you can go to the next person, let's just solve this hitch that we are facing now.
Stop sharing screen over there. Stop sharing the screen.
Stop sharing screen.
I want to open this. Yes, stop. Click stop share.
I've stopped it.
Can you see my slide?
Yes, yeah, that's fine. Yeah. Thank you, Uncle Tiger.
All right, go ahead. Go ahead.
Okay,
please, you
so
have 4 minutes left.
Oh, my time is gone. Thank you so much for this opportunity. I want to appreciate the organizers of this conference for this opportunity to speak on this paper titled Waste to Energy Innovation for Optimizing Electricity Case Studies, Abia State. And this studies aim at investigating how municipal solid waste can be transformed from an environmental burden into a reliable source of electricity, while simultaneously supporting sustainable development and improving urban sanitization. So that's what the research, the paper is all about. Can we go to slide 2, please? Slide 2.
It's to affect.
Can you move to slide? Okay. So by way of introduction today, I want to say that it's been seen that Abia State faces 2 interconnected challenges, and that's it's a problem that is Nigerian actually, not just Abia State. The problem of inadequate electricity supply and increasing volume of waste. At a time in Nigeria, the city of Aba was plagued with waste, but now it's better. So rapid urbanization, particularly in Abia and Aba and Umahia, has increased waste generation distribution, much of disposed dumping at that time when this research was done. At the same time, household and industries remain dependent on diesel, petroleum generators due to unreliable grid issues. And then the last keynote speaker, Uren, also pointed this out that an average Nigerian state faces about 8 to 12 power outages daily. So the aim of this study is to, slide 3, please. The aim of this study. Slide 3.
I'm just learning when they present, just for me to learn so that.
Okay, the aim of this study is to develop.
Time comes presenting aims and objectives.
Can I hear myself, please? The aim of this study is to develop a planning level decision framework for waste to energy deployment in Abia State. Specifically, we assess the state's waste to energy potential characterized by the dominant waste streams. We evaluate the hybrid conversion technologies and estimated electricity generation, economic performance, and greenhouse gas reduction potential. Importantly, we sought to create a framework that can be replicated in other states facing similar waste to energy challenges. Next slide, please. Next slide, please. Previously, the research gap, what we know at the moment is that previous studies have shown that Nigeria possesses significant waste to energy potential challenges. However, most research focuses on the major cities like Abuja, FCT, and there's limited guidance for cities like secondary states, we'll call them like Abia State. There's therefore a lack of integrated framework that will connect waste characterization, the geographical feedstock distribution, the energy modeling, and economic assessment. Hence, this study is addressing the gap that exists by providing a state-level planning framework tailored specifically to the state of Abia. And then next slide, please. Our methodology was fourfold. We adopted a qualitative analytical approach using secondary data from peer-reviewed literature, international reports, and governmental publications published between the year of 2015 and 2026. We first estimated waste generation based on population, per capita waste productions, and then in small areas, and then we characterize waste composition, model energy recovery from anaerobic digestion, thermal conversion technologies, and finally evaluated economic indicators such as levelized cost of electricity, LCOE, payback period, and avoided greenhouse gas emissions. Next slide, please. Ladies and gentlemen, and based on our study, our analysis indicate that Abia State generates about 0.85 to 1.05 million tons of waste annually, and organic waste represents the highest fraction, accounting for more than half of the waste stream in Abia. Based on this based on the resource available, we recommended, we said a hybrid waste to energy system could provide between 35 to 55 megawatts of electricity if practiced, and the estimated levelized cost of electricity ranges from 8 to 12 USD per kilowatt. And also at the same time, this system will avoid between 250,000 to 400,000 tons of carbon dioxide emission annually. Next slide, please. The key insights we could gain from this is one of the key insights, key findings that success depends on not just on the quantity of waste, but also on its spatial concentration. And we would like to say that Abia and Umma here emerge as the most suitable deployment corridors because they generate consistent commercial and industrial waste. Our results also show a hybrid approach that is preferable. Anaerobic digestion being well suited for the wet organic waste, while thermal conversion technologies being more suitable for the dry combustible residues. Finally, institutional arrangements such as reliable waste supply agreements, effective collection systems, and bankable electricity tariffs are just as important as the technology itself. And finally, in terms of the limitations and conclusion, next slide, please.
Yeah, not next month.
Ladies and gentlemen, I have to admit that the study has certain limitations. The waste generation figures are planning estimates rather than audited weight bridge measurements, and the economic results are sensitive to assumptions regarding collection efficiency, financing cost, and plant performance. Nevertheless, the findings indicated that there's a way forward for hybrid waste to energy portfolio, which is technically and economically feasible for Abia State. We therefore recommend detailed audit waste across all the local government areas of Abia State, a pilot source separation program, bankable power purchase, waste supply agreements, comprehensive environmental EIAs, and a phased implementation strategy, beginning with anaerobic digestion and material recovery before expanding thermal conversion capacity. Thank you. Thank you.
Thank you. So thank you, Dr. Chilman. Thank you very much. Off. Over to you.
Thank you, our presenter, for a wonderful talk. Do we have any comments from the floor or from online? Any comments? No comments? Any question for our presenter? No one. Thank you.
Thank you, sir.
Hello?
Please.
Hello? Hello?
Yes,
Hello?
yes.
I'm audible, sir?
Yes.
May I
Please
audible?
go ahead.
Yes. Sorry for sir being late because of we are from India and we are facing the problem of transactions, some kind of money. That's why. May I start, sir?
Please hold on. I'm trying to download your slides. Please just give me a minute.
Okay.
Just a minute, please.
Okay.
It's everything. It's still downloading now. It's a network. I don't know why the network is like the same. It's not completed. It's about to it's a little now. Maybe the way you position that out, I don't know. Please, just a minute, please.
Yes.
Yeah. Yes. Can you see your slide now?
Yes. May I present, sir?
Yes, go ahead, please.
Minute, sir.
Please go ahead. You have just 5 minutes.
Yes.
Go ahead, please.
Yes. First of all, I would like to express my sincerely gratitude to our respected person, judges, faculty members, and all the participants for giving me this opportunity to present our research. And my name is Ahiaise, and this is my team members, Chade, Prashkare, Kunal Chaudhary, and Mayuri Patil and Rohit Patil. Yes, we are from Department of MCA, SVKM Institute of Technology, Dhule, Maharashtra, India. Today, I am going to present our research paper, the machine learning health insurance fraud detection using explainable AI. Sir, the health insurance fraud has become one of the major challenge in the health industry. Fraudulent claims not only cause huge financial losses insurance companies, but also delay genuine claim approvals. To solve these problems, we develop a machine learning based fraudulent detection system integrated with explainable AI using SHAP, which not only predicted fraudulent claims with high accuracy, but also explain why they. Next slide, please. Our problem statement is health insurance fraud is increasing rapidly across the world. Every day, insurance companies receiving thousands of medical claims. Traditionally, these claims are verified manually by experts. However, manual verification has several limitations. It comes a lot of times. It requires significant human efforts. Human errors are possible, and fraudulent claims sometimes to understand. As a result, insurance companies suffer huge financial losses. Genuine customers experience delays in a claim approval. Therefore, there is a need for an intelligent automated fraud detection system. Our objectives were the main of our work are to accurately detect fraudulent insurance claims, to compare multiple machine learning algorithms, to improve the accuracy of claim approval decision, to make the prediction transparent using explainable AI. Unlike traditional black box models, our system also explain why a particular claim is classified as fraudulent. Now, let me explain the proposed methodology. Next slide, please. This slide explains the complete workflow of our proposed system. The methodology consists of multiple stages. First stage is data collection. Data collection means that initially we collect a health insurance claim data containing various patients and claim related attributes. The dataset includes information such as claim amount, patient's age, provider information, medical diagnosis, treatment details, and risk related features. Then second is data processing. Data processing means that before training the model, we perform processing. This includes removing misvalues, encoding category variables, features whenever required, and handling inconsistent data. This improves the quality of dataset. Third step is that feature engineering. Feature encoding means that important feature influencing fraud detection where selected unnecessary attributes were removed to improve model efficiency and reduce computational time. Next one is model training. Model training means that we train multiple machine learning algorithm, includes logistic regression, decision tree, support vector machine, and random forest. Each model was trained using the same dataset. Next one is model evaluation. Sorry, model evaluation means that after training, each model was evaluated using several performance metrics: accuracy, precision, recall, F1 score, and ROC score. Based on the evaluation metrics, we selected the best performance model. Next, explainable AI. Explainable AI means SHAP. Explainable means that finally we applied SHAP. Yes, SHAP additive explanations. SHAP helps explain means that why a prediction is fraud, which feature contribute most, and another is the importance of every input feature. This increase trust in the system because user can understand the model decision. The architecture shown on the right side. This side. Yes. Now let us look the. Yes. Now this is the architecture. We can check the suspicious activities whenever the user can check. Please next slide, please. We can check the experimental result. In this slide, we compare the performance of different machine learning methods among the all evaluated models. First one is random forest achieve the best overall performance. Its performance metrics are accuracy 97.49%, precision means 98.00, and row course is 95.89. This value indicates that the model can identify fraudulent claims with every high reliability, and confusion matrix shown the here demonstrate that most legitimate claims were classified correctly. Fraudulent claims were also detected with the every few false prediction. Due to its superior performance, random forest was selected our final prediction model, and this result proved that our approach is highly effective for real world fraud detection. Now I will be brief demonstrate the application. This is the to make our research practical. We develop a web-based application, claim details through a simple interface. Once the information is submitted, the trained random forest sorry the trained random forest, it's check the legitimate fraudulent and prediction is instantly. This enables insurance company quick identify suspicious claim before approval, such as automation reduce manual work speeds up claims and minimize the financial losses. Like that, whenever we enter the data, the user can check their data, and this is check our model, the claim is legitimate or fraudulent. Then I will, please next slide, I will move for the next slide. Explain one of the biggest challenge of machine learning is that many models behave like black boxes. User often do not know why predictions was made. To solve this problem, we integrated Sharp explainable AI. Sharp provides features-wise explanation for every prediction. It identifies which factor contribute most, whether a feature increasing or decreases fraud probabilities, and the impact of every variable on the final decision. Our analysis shown that the provider risk score was one of the most influential feature affecting fraud prediction. Therefore, instead of simple saying a claim is fraudulent, our system clearly explains the reasons behind the prediction. This greatly improves transparency, trust, and decision making for insurance investigation. Now I include the presentation. Next slide, that conclusion and future work. Conclusion is that from our research paper, we conclude that random forest produce the highest performance among all evaluated model, and our proposed system accurately detect fraudulent insurance claims. Then Sharp makes the prediction transparent and interpretable, and the developed web application enables real-time fraud predictions. Overall, the system support faster, smarter, and more reliable insurance claim verification. Now I will move forward to future work. In future, we plan to deploy the system on hospital and insurance database, and develop a mobile application support AI-based real-time claim verification, and improve prediction further using advanced deep learning techniques. That's all about. Thank you to everyone for your valuable time and attention. Thank you.
Thank you for your presentation. Thank you very much. Thank you.
Hello, thank you for your presentation.
Yes.
Thank you. Do you have any comments? Do you have any comment? Anybody, any question? Mr. Presenter, thank you for your presentation.
But I did 62. 62.
No comments, no question. Online. Is there any
Okay.
online?
Thank you, sir.
In your presentation, you talk about fraud and how to control it. What is our take home in all your presentations? Contribution to knowledge. Your contribution to knowledge, the paper's contribution to knowledge, just in a sentence.
Sorry, sir. Could you repeat, sir?
Yes. What is the contribution to knowledge? This paper you presented, could you tell us the contribution to knowledge?
We don't understand, sir. Sorry.
Yeah. What is the take home from this paper? The take home for the participants that have listened to your presentation.
So what do you think will reflect on when we get back to our various organization, educational institution, and how is it going to be useful? So can you tell us?
Sir, actually, this is my application, and whenever the insurance company are check their claim like that. Sometime the age will be the first the first we are required the validation means that the age will be of 60, the user will be not validate that are the legitimate claim or fraudulent claim. Yes. Whenever we found the information of the sorry sir.
All right, thank you very much. Thank you. Thank you. Thank you. Thank you. I'm going to call on the next presenter. Thank you.
Yes, sir. Thank you very much, sir.
Thank you very much for your presentation. We appreciate it. You are welcome.
Yes, sir. Yes, sir. Yes, yes.
We're going to call on the next presenter, Dr. Unduka. Please, can you please come forward for a presentation? Dr. Unduka, is she around?
Knowledge. You, the perfect.
63 should come and present.
I'll be presenting on her behalf.
Okay. Are you one of the co-authors?
Yes, sir.
Okay, please, I'll give you some minutes. Please kindly introduce yourself.
Okay, thank you so much. I am Dr. Zemina Emmanuel from the Department of Biochemistry here at University of Nigeria, Nsukka. With my co-author, Dr. Nduka, Robert Fischlaka, Dr. Ijoma, and the rest. We are here to present on a topic titled Biochemical and Kinetic Study of glucose oxidase from asparaginous Niger using Fezoli vulgaris peroxidase as a coupling enzyme. Next slide, please. So we are going to look at just briefly the introduction, the materials and methods, the results, and also the conclusion. Next slide. Next slide, please. Yeah, by way of introduction, glucose oxidase. Yeah, I can see it. By way of introduction, glucose oxidase is an oxidase reductase and catalyzes the oxidation of glucose into gluconic acid, releasing hydrogen peroxide. This enzyme catalyzes this reaction through a mechanism called the tip-form bye-bye mechanism, in which the two substrates are involved to release two products. And then this is used to monitor glucose level. Also has found application in biosensor and in design of biosensor and also in monitoring of activity of enzymes. We can use it, and because this enzyme is produces non-color products, so then it's a need to couple when we want to assess for the activity of the enzyme, to couple it with another enzyme called peroxidase. And this peroxidase can be found in plants, in animals, and also in microorganisms. But for a very long time now, peroxidase that have been used have been from horseradish peroxidase, root of ginger, root of garlic. They are found to be high stable. But there is now high purification of this enzyme because of their cost necessitate the need for us to look for alternatives to source for this particular enzyme of interest that we can use as a coupling in a couple assay to determine the activity of glucose oxidase. Next slide. By just simple mechanism, next slide. By just simple mechanism, we know that glucose oxidase hydrolyzes oxidizes glucose and then release gluconic and hydrogen peroxide. So hydrogen peroxide is one of the primary substrates that peroxidase degrades and then reduces it into water. Then, having done this, we couple it with a co-substrate called odor anisodine for us to be able to detect color because either gluconic acid nor hydrogen peroxide is able to give us that. So this is what we call majorly indirect coupled assay. Of course, it's a continuous assay because the hydrogen peroxide produced during the hydrolysis of glucose is going to be used as a substrate for the peroxidase coming in. So over the years, we have been relying personally buying this enzyme from Sigma US. It takes 6 weeks to get here. Meanwhile, we have source of this enzyme which we can purify here and use them to do what we can do. Because for the glucose oxidase, we can caution microorganisms, majorly fungal species that have been found to express this more. And then we caution them, but for us to assay and determine the activity of this enzyme, we need a coupled enzyme glucose oxidase. And that is the key objective of this research, for us to extract this peroxidase from fecal vulgaris, normally known as green beans, we will use, and then to also purify the enzyme, partially purify it and use it as a couple assay, and also to go ahead and subculture the aspergillus we isolated and then use it to optimize the production of this enzyme. Then purify it through 3-step purification step involving ammonium sulfate precipitation, although it's after profiling, of course, and then involving dialysis to the salt and further gel filtration chromatography to get our partially purified enzyme. Next slide, please. So the major source of this enzyme is we obtain them from the market here in Soka here, and then we weigh a certain amount up to 100 grams of it, and then extracted using a cold shade buffer. Then activity was also carried out using odianisidine as a coupling substrate, a co-substrate, of course. And we also find the activity and as well as determine the protein concentration of this enzyme by a method of Lowry et al. 1951. Next slide. Next, we went into production of glucose oxidase, of course, from Aspergillus niger, and I will be able to produce the caution media, and these are the constituents involving the nitrogen sources, the carbon sources, the iron sources, and the rest of them. We also have to assay for the activity of the glucose oxidase, and then measure the absorbance, of course, optical density as 500 nanometer at the visible region. Next slide, please. So we now also engage in purification strategy, as I mentioned earlier, using ammonium sulfate precipitation to sort out the protein of interest. And then because ammonium sulfate is attached to it, we need to remove the salt through dialysis and finally get to the gel filtration chromatography using the G200. Next slide, please. So these are results. This is the gel filtration chromatography of the federal vulgaris peroxidase. Looking at that place, you will see the activity curve under the protein concentration. It's important for us to determine this. The one you have the higher, the most active fraction are where you have the peaks, at say from peak 10 and 11 to peak 19 shows highest activity. So we put those active fractions for next characterization of the enzyme, while the protein concentration we expand using UV visible at 280 nanometers. And we plot both of them together to get this chromatogram. Next slide, please. So this is another one for the glucose oxidase called GOS or GOS. And then you can see also the protein concentration curve and also the activity curve. Next slide. The active fraction here also will also put together and then for further analysis. Now, this is the summary of the purification table at each step. A summary of the purification table at this step showing the activity and showing the protein concentration. To find out that here the specific activity of the enzyme increases as soon as we begin to purify from one purification step to another. But it gets a little bit down to separate G200, where we use it to purify and find out that the activity slightly drop. One of the questions I ask is why will it drop? Because we know that purification goes with increasing specific activity of a protein, target protein. But I find out that during dialysis, because you create a concentration gradient and there's inflow of water, so the dialyzed form of the enzyme gets a little dilution, thereby decreasing the activity as soon as you pass the dialyzed form to the jet filtration chromatography. However, when you compare the specific activity to that of the ammonium sulfate and also the crude, you find out that there is increase, showing that purification has occurred. Then we have up to 7.7 folds of purification with 1.2 recovery of the enzyme. Next slide, please. So this another one for the glucose oxidase. The similar things happen here, but in this case, you can see the specific activity of this enzyme to be at 143.6, of course, milligram unit per milligram of protein of the enzyme. And then we have achieved about 3.3 folds of purification with 1.7 recovery. Next slide. So we went into biochemical characterization of glucose oxidase because that's the major target. So say what could the effect of pH on the partially purified enzyme look like? And at what pH will this glucose oxidase act most? And we find out from our study here that the best pH and where this enzyme acts from this pH is at 5.5 pH 5.5, which means more of acidic enzyme and catalysis is storage at acidic region. So 5.5 becomes the optimum pH of this enzyme from our findings here. Next slide. Next slide, please. We also look at the effect of temperature, of course, effect of temperature on the activity of this enzyme. And we'll find out that the temperature optimum for the catalytic activity of glucose oxidase is at 45 degrees Celsius. So this becomes the optimal temperature whereby the three-dimensional structure of this enzyme is well positioned to carry out maximum catalysis. So because we know that increase in temperature increase the collision between the substrate and also the active site of the enzyme, causing the protein to fold into a good and functional conformational state to carry out catalysis. Next slide, please. So in terms of the kinetic mechanism, we also look at the effect of substrate concentration on the activity of glucose oxidase. And then we start increasing the different concentration of glucose, and then at fixed concentration of the co-substrate, of course, and we were able to get a rectangular hyperbolic curve, which is with respect to the Michaelis-Menten curve. It is the rectangular hyperbolic curve that we now use to transform it into the Lineweaver plot of initial velocity data, and we were able to calculate our kinetic parameters, the Km and the Vmax. And the Km of this is 5.66 millimolar, while the Vmax is 16.67 micromole per minute, indicating that the enzyme has affinity to the substrate, in which case Km here simply signifies the substrate concentration at half the maximum velocity, meaning that this is the substrate concentration when half of the active site has been saturated with substrate. Next slide, please. So in conclusion, we have that green beans, which is Fetori vulgaris, it's a viable source of peroxidase, and we can use it in coupling as a coupling molecule, coupling marker to assay for glucose oxidase. And Fetori vulgaris is found everywhere, sheep, and this enzyme has proven to be robust because we can use it. But recently, we expanded this research and we started studying it and found that even the thermostability property is very high. So Fetori vulgaris represent one of the major source alternatives to horseradish peroxidase that we can use in biotechnological application and biosensor and different formulation in biotechnology. Thank you.
Thank you very much.
Thank you.
Oh, what is it?
Thank you. Thank you, our presenter. Do we have comment from the floor? Do we have comment on what he presented? No comment? Any question? Are we tired? Okay, thank you.
Thank you so much.
Are we taking home from your, what are we taking home from your presentation? What actually
Thank you very much.
the summary?
Yeah, in summary, we find out that, yeah, thank you so much, Prof. In summary, we've discovered that the importation of this enzyme from Sigma cost us a whole lot before it gets to Nigeria. We can actually source for our local source and we still maintain very much high activity. So instead of relying on them to wait before we carry out this, we can simply source it around our own resources here, which are readily available and cost effective. And then we get this particular important biomolecule for biotechnological application.
Thank you for your presentation.
Thank you so much.
Do we still have anybody remaining? Is there anyone in the house who has presented?
Please, if you have not presented, can you please use the raise hand button?
Anyone?
I don't think there's anyone.
Track 2.
They're not presented. No, they are not online. Please, paper ID 66. Paper, yes, 66. 66. Yes. Paper ID 24. Paper ID 37. Paper ID. Please, paper ID 66. They are online. Can you please share the screen? Paper ID 24, 37, 38, 52. So it's assumed that we've all presented our papers. Over to you.
Okay, since nobody is indicating that they want to present online, so we can now invite the conference chair if she's going to round up the section. Or okay, or should we close this section? Okay. Okay, we wait to see if we still have people that want to present. Okay.
Yeah, thank you very much. Yeah, thank you very much for all our presenters online and for all the physical presenters. Yeah, I want to say that in the absence of none for now, then we'll just sit down and enjoy the music while we wait for others in the different breakouts to return to the main hall. Thank you. So let the music continue until, assuming there is anyone online that has not presented, please indicate so that we can call your paper for presentation. Thank you.
Taiwan, the United States, Nigeria, and beyond. Explore ground at the Federal University of Allied Health Sciences Main Auditorium, Enugu, Nigeria. Scan the QR code to register today. Innovation begins with ideas. Great ideas transform lives and shape nations. Welcome to Ahiaise Conference 2026, the second international conference on arts, health science, artificial intelligence and sustainable systems. Join renowned keynote speakers and researchers from the United Kingdom, South Africa, Taiwan, the United States, Nigeria, and beyond. Explore groundbreaking research, global collaborations, and innovative solutions under the theme, Integrating Arts and Sciences for National Development. Join us on the 22nd and 23rd of July, 2026, at the Federal University of Allied Health Sciences Main Auditorium, Enugu, Nigeria. Scan the QR code to register today. Innovation begins with ideas.
Are you seriously? Yes, sir. Dr. Rajingant, can you hear me? Are you ready for your presentation?
Yes.
Dr. Rajingant?
Yes, can you hear me?
Yes. He joined not quite long ago. I'm talking to him, he's not responding yet. Hello, Doc? Dr. Rajingant?
Can you hear me, Doctor?
Please, if you can hear me. Go ahead and make your presentation. We can see your slide. This can zoom.
Am I audible, doctor?
Yes, but he's not muted. He should talk.
It's your volume.
We can't hear you. Could you please speak up?
It's your volume because we can't hear you.
Please.
Can you hear us? Increase your volume so that we can hear you.
Can you hear me?
Yes, we can hear you.
Please tell me, can you hear me? Am I audible? Yeah. So very good afternoon. So this is Dr. P. Rajinikanth from India. So today we are going to present about discrete ETK through the generalized alpha difference operator. We have three authors. So in this paper, we are dealing with the Newton cooling law by using a forward difference operator with a alpha decay. So actually the classical Newton cooling law, that is the d by dt of dt, so equal to minus k t of t minus t. So actually why this classical Newton cooling law fails? So here there is no memory about the past temperature, and the real sensors give data every h seconds or minutes or hours. So we need a discrete model that can remember the history, that means the past temperatures. So that is why we used what is a new formula, the new difference operator d of t of t, what is a t of t plus h minus alpha t of t by h, that alpha always belongs to 0, 1. The discrete cooling law can be written as d of dt equal to minus k t of t minus t. So what does that alpha do? When you take alpha is equal to 1, no memory, but fast, but inaccurate. But when alpha is less than 1, adds damping memory, slower but more realistic and accurate. So this is a solution for our what is a Newton's cooling law by using a forward alpha difference operator. So d of t equal to ta plus t naught minus ta alpha minus kh power t minus t naught over h. And then when you find out the stability 0, the condition is 0 less than alpha minus kh less than 1. Take away. By tuning alpha, we control how fast heat decays. So we are taking two applications. So one first application CPU thermal management, and the second one forensic time of death, and finally conclusion. So when you take a gaming laptop, shut down at 85 degrees Celsius, room temperature is 25 degrees Celsius, data logged every 2 minutes. Actually, when you take a classical method, that means alpha, when you take alpha is equal to 1, it will take 18 minutes to reach 30 degrees Celsius. But in our model, when you take alpha is equal to 7, it takes 12 minutes to reach 30 degrees Celsius. Why it matters? Alpha is less than 1 models the heat sink plus fan inertia. This is a 32% faster and more accurate prediction cooling times. And the second application for forensic time of death plus a conclusion. Scenario, body found out at 30 degrees Celsius, normal temperature 36 or 37 degrees Celsius, room temperature 20 degrees Celsius. So data every 1 hour. When you take a classical model, alpha is equal to 1, that estimate 4.5 hours ago. But in our model, when you take alpha is equal to 0.85, estimate 2.1 hours ago. Why it matters? Alpha is less than 1 accounts for clothing insulation, reduces overestimation error by 57%. That conclusion alpha tunes memory for a real system, but it is not available in classical Newton's law of cooling. So this is our conclusion of the paper. Thank you. Thank you very much. And one more paper.
Dr. Whitingham, please, you have just 2 minutes left. 2 minutes left for your presentation, please.
Yeah.
You have 2 minutes. 2 minutes, please. I hope you can hear me clearly.
Yes.
Please, you have 2 minutes. 2 minutes left.
Not get your point, doctor.
Please go to your results and conclusion, please. Conclusion, please. Conclusion. Hello, Dr. Whitingham.
Yes.
Conclusion, please.
Conclusion, yes. Oh, yes.
All right, thank you for your presentation. We appreciate you. Thank you very much. Thank you.
Yes, doctor, may I continue? The second paper.
Okay.
Yeah.
Please, you have just 4 minutes to make the presentation.
Yeah. Good afternoon to everyone. So this is our another paper, Ayr-Ulam stability of the Tetranaki recurrence in real to Banach spaces. So we have the 4 authors. So already we have what is a result in Fibonacci sequence and Fibonacci sequence, but there is no result for a Tetranaki sequence. So we find out what is the stability, Ayr-Ulam stability for a Tetranaki sequence. So that means a 4th order difference equation. We are taking 4th order difference equation and we are finding stability. Okay. So Ayr-Ulam in 1940, Ayr-Ulam asked one question: if a function goes to satisfy an equation, is it close to an exact solution? So we are trying to give what is the answer for this question in this paper. Classical recurrences, already we know Fibonacci sequence, Fn equal to Fn minus 1 plus Fn minus 2. And the Tetranaki sequence, so we may see this Tn equal to P, Tn minus 1 plus Q, Tn minus 2, etc. Okay. So the gap, stability of 4-term Tetranaki in two Banach spaces was open. No one wanted to find out the result about what is Tetranaki stability. So our goal, prove higher Coulomb stability and find explicit error bound Kfc. So let Y be a real two Banach space. The equation, this is our Tetranaki equations. When you find out the characteristic equation of this equation, we get lambda power 4 minus P lambda cube minus Q lambda square minus R lambda minus S is equal to 0. When you find out this, when you find out the roots of this characteristic equation, we may get the roots alpha 1, alpha 2, alpha 3, alpha 4, such that modulus of alpha 2, alpha 3, alpha 4, which should be less than 1, that should be less than modulus of alpha 1. So we can use this determinant, one more determinant in this paper. Now F is epsilon approximate the F of W. So this is what is a higher Coulomb stability theorem. Okay. So there exists a unique exact Tetranaki function E such that so we get this result. Okay. And here the stability constant K equal to 1 by V into V1 divided by 1 minus determinant of alpha 2, where V1 depends on determinant of alpha 2, alpha 3, alpha 4. So idea, we are using a directing method and green kernel in the geometric series in this tip. The special case when you take PQRS equal to 1, so we will get what is this results, that is the characteristic roots lambda 1, lambda 2, lambda 3 and the lambda 4. So when you find out what is a corollary, when you take the corollary, you will get this result. And then when you take the numerical illustration, that means when you take a numerical illustration, we are getting what is epsilon equal to 0.01 and the true Tetranaki sequence is within 0.0 to 0.08. So what is the impact of this paper? Quantifies how photofixation propagate in 4-term recurrences. So, and finally our conclusion, we proved in this paper, we proved Ahiaise Coulomb stability of 4th order difference equation, that means a Tetranaki equation in two Banach spaces, and derived explicit stability constant using van der Moor determinant. And then we find out the classical case, we are taking P, Q, R, S equal to 1 and we found the bound is 2.08 epsilon. And then fourth one, extend earlier the Fibonacci result to 4 log. So our future work is what is we are going to take higher order references and we are going to take the first two normal spaces, random two normal spaces. Thank you.
Stop. Thank you very much. Thank you for your presentation.
Thank you.
Thank you. It's so expensive. No.
Thank you very much, Dr. Raju. If I may ask, please, what is your paper ID? Because I didn't see it reflected.
He has written himself.
Your paper ID is number one, ID what?
Dr. Rajinikanth, I hope you can hear me. Please, could you please tell us your paper ID? We could not identify the tracks your paper belongs to, so we need to stop it. What is your paper ID? What's your paper ID?
51 and 61. Paper ID.
You said?
Paper ID is 51 and 61.
Okay. Okay. So I thank you. Thank you.
You said it's 21 and 61.
It says 61 and 62.
Okay, 61 and 63. Okay, okay. But also, I hope you sending your payment receipt. Try to upload it through the CMT portal. And then, I don't know if anybody has a question on Dr. Raji's presentation. Any question for him? Or any contribution? What about online? Do you have any? Yeah, thank you very much, Dr. Raji. Your presentation is very good and people understand you very well. I think that is the reason we don't have any question. Thank you.
Thank you. Thank you.
Yeah, is there any other? I think so far we are all here now, even from our different breakout rooms. And I want to appreciate everyone, both all the people online, all the those online, all our international partners. I want to appreciate everybody, those virtually and physically. All right, while we are still waiting, please let the music continue and please keep enjoying yourself. And now and go ahead for networking. This is time for networking while we are waiting for track 3 to finish and end their technical section. Please make sure you check people by your side, know their names, know what they are doing, exchange pleasantries, and in fact, enjoy yourself. Thank you.
Innovation begins with ideas. Great ideas transform lives and shape nations. Welcome to Ahiaise Conference 2026, the second international conference on arts, health science, artificial intelligence and sustainable systems. Join renowned keynote speakers and researchers from the United Kingdom, South Africa, Taiwan, the United States, Nigeria, and beyond. Explore groundbreaking research, global collaborations, and innovative solutions under the theme, Integrating Arts and Sciences for National Development. Join us on the 22nd and 23rd of July, 2026, at the Federal University Allied Health Sciences Main Auditorium, Enugu, Nigeria. Scan the QR code to register today, or innovation begins with ideas. Great ideas transform lives and shape nations. Welcome to Ahiaise Conference 2026, the second international conference on arts, health science, artificial intelligence and sustainable systems. Join renowned keynote speakers and researchers from the United Kingdom, South Africa, Taiwan, the United States, Nigeria, and beyond. Explore groundbreaking research, global collaborations, and innovative solutions under the theme,
Is there anyone in this call that has something to present that has not presented? If you have a paper to present and you are not given the opportunity to present, please can you just indicate so that I'll give you the opportunity to come and present now. Because I know there were categories of staffs that wanted to present, but did not pass their papers through the CMT portal. So if you are in that category, please, I want to give you opportunity to present now. You can just indicate and then we'll call you, you come out and present your paper. But if they are not around, no problem. DJ, continue, please.
I'm so focused on such reference to purpose knowledge. Such paper for useful on the level regions, processional analysis and the rapid globalization, the rapid digitalization of that infrastructure has created unprecedented opportunities for improved patient care. On the other hand, this imposed those file systems across conflicts, the complex cyber threats and regulatory framework. This review examines other infrastructure pieces and infrastructure additional orders, data protection, and cybersecurity governance for internet and data infrastructure. Through synthesis analysis, comparing the region, not so much. Really there. Yeah, that's one of those. My research was focused on
Yes, because no, I know everyone translate.
Everyone is here now, right? Please let us settle down so that we can close the session, then we can all go home, please. Please, for those outside, can they all come inside? Let's close. It wouldn't look nice that we have this wonderful conference and we just live like that. It doesn't look nice at all. Can we all come in? For those outside. Please, are all the tracks here now? Are they all here? Shegu, can you confirm if they've closed all the tracks?
Yes, they've closed all the tracks.
They've closed, okay. Okay, I want to invite Profina to do the closing remarks so that we can all leave. Please let us welcome her with a round of applause. Thank you, my able conference manager. You have done a very wonderful work. I hope all viewers online you are on. So, yes. All right. On behalf of IEEE Skill Up for Region 8, United Kingdom, and the University of Johannesburg, South Africa, and the University of Chichester, and all our partners in the diaspora. I want to use this opportunity to say thank you. I want to appreciate all your efforts, all the sacrifices you've put on to make sure this conference is a success. So I want to say thank you for all the staffs in the allied
health sciences all across Nigeria, from all the different universities that are centered here. I want to say thank you. We are grateful that all the sacrifices you've put on to make this conference a success. We are praying that God will bless you and will replenish all your pockets. And I do know that by this time, you have at least gained one or two things in this conference. And I'm sure the networking will continue and we will also meet in due course. Thank you very much. So as we go to our various places, and for those that will be traveling out of the country, because some came out of the country to join this very conference, as you know, it is an international conference. So for those that will be traveling back, we pray that God will grant you joining mercies. And then for those of us that are within the country, that will be traveling back to different places, different states, I also wish you joining mercies. I say, may God bless you all. Thank you. So finally, let me call the conference manager to give a goodwill message for the closing ceremony.
Please, can we give a round of applause? I believe Profina has really thanked everybody. So I wouldn't really start thanking all over again. That would be repeating. But honestly, you all have been wonderful. Every one of us that attended this conference, we've all been wonderful. As students, thank you so much for coming. Thank you. And I believe you learned something. I want to believe that. Not right? Not right? Am I right, students? Yes, I believe you learned something. Thank you for being good ambassador of your school. You didn't make noise and you asked intelligent questions. So I want to appreciate you especially. You are our future, and once we get you and get it right, then I believe we've gotten the nation. So I want to thank everybody. I want to thank you in a special way. Profina has thanked everyone individually, so I want to make a general thanks before we all depart. Please, thank you so much. And very soon, I want to believe we'll have a third international conference. Not so. I'm talking to you. We're going to have a third one soon, right? Great, great. So please, as you go to various, I believe the Lord will lead us all. Thank you, everyone. The media, thank you for the music, everything. I want to appreciate you. Our IT team, thank you so much. You really tried your best. Please, all the committees, the LOCs, thank you, Chair, for coordinating your team. You did a great job. Thank you so much. Thank you so much. All the committee members, every represented. I'm seeing very few people here. Please, all of us are not here. I want to thank you. Success, we didn't forget. You've been doing a good job on the ground. Thank you so much. Please, if I didn't mention your name, please don't be angry. Just that I have each and every one of you in mind. All our chairs and co-chairs, thank you so much. You made the different tracks well. So much. Please, announcement. All the chairs and co-chairs, please submit your summary to Profina, please. Please, very important. Submit them to her so that we can get it together and help in the communication. Please, we want that too. Please, all the committee members present, please wait behind after the conference. We'll have a brief meeting before we depart. So please, I want to officially declare the conference closed. Please, a round of applause. Thank you, everyone, and goodbye.
Good pleasure.
Class is so backwards. Sir, class is so.
Pictures, no pictures. And let's make memories. Pictures and memories, please. Let's have group pictures outside. Yes, we'll have the pictures. Yes, that's please. Please, let's all go outside group pictures.
Oh, ní flash rárá ni. Ó yẹ kó gẹ́ sí machine. Ó ti sọnù. Lápá ẹ̀yẹ tẹ̀lé flash.
I know, I thought I understand. Yeah.